Imagine this. You walk into a modern IT company. Everything you see, applications, data, dashboards, even user logins, is not running on physical servers inside a room. Instead, everything is running somewhere in the cloud. Now here's the interesting part. That cloud is what companies like Microsoft Azure provide today. Welcome to Azure Fundamentals Overview. In the next few minutes, we are not just going to learn theory. We're going to understand how the real IT world actually runs today and how cloud computing has completely changed the way businesses operate. Whether it is banking, healthcare, e-commerce, or even small startups, everyone is moving from traditional infrastructure to cloud platforms like Microsoft Azure. What you will learn in this session. By the end of this session, you will clearly understand what Azure Fundamentals is all about, why companies are moving to the cloud, the core exam objectives you should focus on, how your career can benefit from Azure skills, the step-by-step learning path, and finally, the real value of Azure certification in today's job market. So here's the real question. If the entire industry is moving to the cloud, where do you stand in this transformation? In this session, we are going to make sure you don't just understand Azure, but you also understand how to position yourself for better IT opportunities, better salary growth, and future-ready skills. Let's begin this journey into Microsoft Azure Fundamentals.
What is cloud computing? Let me start with a simple story. Imagine you are working as an IT support engineer in a company with 500 employees. One morning, the application team raises a request. They say, "We need a new server urgently because our current application is running out of resources." Now think about how things worked 10 or 15 years ago. The IT manager would need to get approval from management. The procurement team would order a physical server from vendors like Dell or HP. The company would wait for delivery. The server team would install Windows Server. The network team would configure IP addresses and firewall rules. The storage team would allocate disk space. Finally, after 1 or 2 weeks, the application team would receive the server. That's the traditional way. Now let's see what happens in cloud computing. Today, the Azure administrator opens the Azure Portal, clicks Create Virtual Machine, chooses Windows Server, selects CPU and memory, clicks Create. Within 10 to 15 minutes, the server is ready. This is the power of cloud computing. Cloud computing means getting IT resources like servers, storage, networking, and databases through the internet whenever you need them. Instead of buying hardware, maintaining data centers, and worrying about failures, Microsoft manages everything for us. We simply consume the services and pay for what we use. Think of it like electricity. None of us own a power plant. We just switch on the fan or AC and pay the electricity bill. Cloud computing works exactly the same way. You don't buy servers. You use them when needed and pay only for usage. Simple example. Let's say you want to watch a movie. You don't buy a movie studio. You subscribe to Netflix and watch what you need. Similarly, companies don't always buy servers anymore. They use Azure and pay only for the resources they consume. Real-time work example number 1. As an IT support engineer, you may receive a ticket saying, "Users cannot access the company application." When you investigate, you discover the application is hosted on an Azure virtual machine. Instead of walking into a data center and checking physical hardware, you simply log into Azure Portal and check. Is the VM running? Is CPU utilization high? Is the network working? Has the VM been stopped accidentally? This is cloud administration in real life. Real-time work example number 2. Suppose your company has 100 employees. Suddenly, the company acquires another business and now has 500 employees. In the traditional world, IT would need to purchase more servers. In Azure, administrators simply increase resources with a few clicks. This is called scalability. Real-time work example number 3. Imagine an e-commerce website during Diwali sales. Normally 10,000 users visit the site. During Diwali, 1 million users visit. Azure automatically adds more resources to handle the traffic. After the sale ends, Azure removes extra resources. The company pays only for the period it used them. This is called elasticity. Interview question. Interviewer: what is cloud computing? Answer: cloud computing is the delivery of computing services such as servers, storage, networking, databases, and software over the internet. It allows organizations to access resources on demand, scale as needed, and pay only for what they use. Key message to tell all audience. If you remember only one thing from this slide, remember this. Traditional IT equals buy servers first, use later. Cloud computing equals use first, pay later. This one line helps most people understand cloud computing immediately. Benefits of Azure. Let me ask everyone a question. How many of you have ever experienced a system outage? Maybe your banking app was down. Maybe your company's email stopped working. Maybe a website became very slow during a sale. These problems cost companies millions of rupees every year. Now imagine if there was a way to reduce these problems significantly. That's one of the reasons organizations move to Azure. Storytelling script. Let me tell you a real-world story. A retail company had its entire application running from a small server room in its office. One day there was a power failure. The UPS battery failed. All servers went offline. The website stopped working. Customers couldn't place orders. The company lost revenue for several hours. The management asked the IT team, "How can we prevent this from happening again?" The answer was cloud computing. The company migrated its workloads to Azure. Now if one data center has issues, Azure automatically redirects traffic to another location. The business keeps running. Customers never notice the problem. Explain Azure benefits like a human. Benefit 1. No hardware purchases. Imagine your manager asks for a new server. Traditionally, raise purchase order. Get vendor approval. Wait for delivery. Install hardware. This may take weeks. Azure. Open portal. Click Create VM. Server ready in 10 minutes. Benefit 2. High availability. Imagine your company website generates 10 Indian rupees lakh per day. What happens if the server crashes? You lose customers. Azure provides multiple data centers and availability zones. If one server fails, another takes over. Benefit 3. Scalability. Think about IPL ticket booking. Normally there are 5,000 visitors. When tickets open, there may be 500,000 visitors. Azure automatically increases resources. After demand reduces, resources scale back down. Benefit 4. Security. Many people think cloud is less secure. Actually, most companies cannot spend as much money on security as Microsoft. Microsoft has thousands of cybersecurity experts protecting Azure. That's why banks, healthcare companies, and governments use Azure. Interactive audience question. If your company suddenly grows from 100 employees to 1,000 employees next month, would you rather buy 10 new physical servers or click a button and scale in Azure? Most people will laugh and answer Azure. Now they are engaged. Real IT support example. Suppose a user reports, "Application is slow." In a traditional environment, check physical server, check storage, check hardware. Azure. Open Azure Monitor. Check CPU. Check memory. Check disk usage. Scale VM if required. Problem solved in minutes. Real Azure administrator example. One of the most common tasks for Azure administrators is increasing VM resources. A manager may say, "Performance is poor." The Azure admin changes the VM from 2 CPUs to 8 CPUs. After a reboot, the application runs much faster. No new hardware required. Audience wake-up question. Ask everyone. What is the biggest problem in IT? Cost, downtime, security, scalability. Let people answer. And say, Azure was designed to solve all 4. Closing statement. If you remember only one thing from this slide, remember this. Azure helps organizations become faster, more secure, more scalable, and more reliable without buying physical infrastructure. Public cloud, private cloud, and hybrid cloud opening hook. Let me start with a question. How many of you keep all your money in your pocket? Probably nobody. Why? 'Cause it is risky. Some money stays in your wallet. Some stays in your bank account. Some may be invested. Organizations think the same way about their applications and data. They don't keep everything in one place. That's where public cloud, private cloud, and hybrid cloud come into the picture. Storytelling script. Imagine you are the IT manager of a bank. Your bank has customer account information, internal employee applications, public website. Now ask yourself, would you put everything on the internet? Probably not. Would you keep everything in your office data center? Also not ideal. So what do most organizations do? They use a hybrid cloud model. Some applications remain inside the company. Some applications move to Azure. This gives the best balance of security and flexibility. Public cloud. Let's start with public cloud. Public cloud means infrastructure is owned and managed by Microsoft. You simply rent resources. You don't buy hardware. You don't maintain data centers. You don't replace failed disks. Microsoft handles all of that. You focus on your business. Simple example. Think about staying in a hotel. You don't own the building. You simply rent a room and use it. Public cloud works exactly the same way. Azure example: Azure Virtual Machines, Azure Storage, Azure SQL Database. These are public cloud services. Real work example. Your company needs a web server urgently. Instead of buying a server for 5 Indian rupees lakh, you create an Azure VM in 15 minutes. The website goes live the same day. Private cloud. Now let's talk about private cloud. Private cloud means infrastructure belongs only to one organization. No sharing with other customers. The company controls everything. Simple example. Instead of staying in a hotel, imagine owning your own house. You have complete control. But you are also responsible for maintenance and repairs. Real work example. A government organization may keep highly sensitive citizen information in a private data center. Interactive question. Ask the audience. Who is responsible if a hard disk fails in your house? Audience. We are. Who is responsible if a hotel room needs repairs? Audience. The hotel. That's the difference between private cloud and public cloud. Hybrid cloud. Now let's discuss the most important model. Hybrid cloud. This is what most organizations use today. Story. Imagine your company has Active Directory running on-premises, file server running on-premises, website hosted in Azure, backup stored in Azure. This is hybrid cloud. Real IT support example. As an IT support engineer, you may work in a hybrid cloud environment without even realizing it. For example, user resets password. Password is updated in Active Directory. Active Directory synchronizes with Microsoft Entra ID. User logs into Microsoft 365. This is hybrid cloud working behind the scenes. Real Azure administrator example. One of the most common Azure projects is extending on-premises infrastructure to Azure. Example. Current environment. Windows Server, Active Directory file server. Azure environment. Backup, disaster recovery, virtual machines. Both environments communicate using VPN Gateway. This is hybrid cloud. Why companies love hybrid cloud? If you spent 5 Indian rupees crore building a data center, would you shut it down tomorrow? Most people say no. Exactly. That's why companies move gradually. They keep some systems on premises and move others to Azure. Real-life example everyone understands. Think about working from office and home. Office only equals private cloud. Home only equals public cloud. Office plus home equals hybrid cloud. Most people today use hybrid work. Most companies today use hybrid cloud. Interview question. What is the difference between public cloud, private cloud, and hybrid cloud? Answer. Public cloud is owned and managed by a cloud provider such as Microsoft Azure. Private cloud is dedicated to a single organization. Hybrid cloud combines both public cloud and private cloud environments and allows them to work together. Closing statement. If you remember only one thing from this slide, remember this. Public cloud equals rent everything. Private cloud equals own everything. Hybrid cloud equals use both together. And hybrid cloud is what most enterprises use today. This slide usually gets a lot of audience interaction because everyone can. Let me take you into a real IT company scenario. Imagine you are working as an IT support engineer in a mid-size company in Hyderabad. The management comes to you and says, "We are expanding. We need a new system for 200 employees. Email, storage, and application servers." Now pause for a second. As an IT person, you now have a big decision to support. Should the company buy everything up front? Or move to cloud? This is where two important concepts come in. CapEx and OpEx. CapEx story, traditional IT thinking. Let's first understand CapEx. Imagine the company chooses the traditional way. They decide, we will build our own data center. Now what happens? They start buying everything. Physical servers worth lakhs of rupees. Storage systems, networking devices, UPS cooling systems, and even maintenance contracts. And the most important part, they pay everything before even using it fully. Now think like a business owner. You are spending a huge amount today for something that may or may not be fully used tomorrow. Let me simplify it. CapEx is like buying a house. You pay a huge amount up front, and then you take responsibility for everything. Maintenance, repairs, upgrades. Workplace reality pause. Engagement shift. Now in real companies, this becomes a problem. Because as an IT engineer, you will notice servers are sitting idle. Maintenance cost keeps increasing. Scaling takes weeks or months. Forecasting future demand is difficult. So businesses start asking a question. Why are we paying so much upfront if we are not even sure of usage? This is where cloud thinking starts. OpEx story, Azure Cloud Model. Modern IT. Now let's switch the model. Same company. Same requirement. But now they choose Microsoft Azure. Instead of buying servers, they simply create resources in Azure. Virtual machines, storage, databases. And here is the game changer. They don't pay big money up front. They only pay for what they use. Let me say it in a simple way. OpEx is like renting a house. You don't buy the house. You just pay rent every month. Now think like an IT operations engineer again. When traffic increases, like a new product launch, Azure automatically scales up resources. When traffic goes down, it scales down and saves cost. This is called pay-as-you-go model. Real company example, make it stick. Let's take a real-world example. Think about Flipkart during big billion days. On normal days, less traffic, fewer servers required. During sale days, millions of users log in at the same time. Heavy load on systems. If they were using CapEx model, servers would either crash during peak time or sit idle after the sale. But with Azure OpEx model, they scale instantly during peak, reduce instantly after peak, pay only for usage. That is business efficiency. Final impact statement, retention line. So if you remember one thing from this slide, remember this. CapEx is buying capacity for future. OpEx is paying only for what you use in real time. And this shift is the reason why companies are moving from traditional IT infrastructure to Microsoft Azure Cloud.
Let me take you into a real IT company scenario. Imagine you are working as a cloud support engineer with 4 to 5 years of experience in a company that supports multiple clients, banking, retail, and healthcare. One morning, your manager walks in and says, "We need to move a new banking application to the cloud, but it must be fast, secure, and scalable." Now here's the real question. Where do you start? Which cloud model will you choose? That is exactly where IaaS, PaaS, and SaaS come into the picture. 1. IaaS, Infrastructure as a Service, real-work scenario. Let's say the banking client says, "We want full control over our servers. We want to install our own OS, security tools, and custom applications." Now, as an engineer, you think, This is clearly a case for IaaS. So you go to Microsoft Azure Virtual Machines, create servers, configure networking, install Windows/Linux OS. Real workplace action. In real work, I have seen teams using IaaS when migrating legacy banking apps. Because these apps were built 10 to 15 years ago, they cannot be changed easily. So we lift and shift them to cloud servers without modifying the core system. Simple explanation to audience. IaaS is like renting an empty apartment. You get electricity, water, building, but you bring your own furniture, design, and set up everything yourself. 2. PaaS, Platform as a Service, Developer Scenario. Now imagine another team in your company. They say, we are building a new customer mobile app. We don't want to manage servers, patches, or OS. We just want to focus on coding. Now, as an experienced engineer, you immediately think, perfect use case of PaaS. So you suggest Microsoft Azure App Services. Deploy application code directly. Auto-scaling handled by cloud. Real workplace experience. In my experience, development teams love PaaS because deployment becomes super fast. Instead of waiting for server setup, which can take 2 to 3 days, they deploy in minutes. Simple explanation. PaaS is like moving into a fully furnished apartment. You just bring your clothes and start living. No stress about furniture, maintenance, or repairs. 3. SaaS, Software as a Service, End User Scenario. Now, let's switch to another department. HR team comes to you and says, we need email, Excel, Word, and collaboration tools for 500 employees. Now you smile and say, we don't build anything here. We simply use SaaS. Real tools used. Microsoft 365, Gmail, Salesforce CRM. Real workplace experience. In every organization I work with, SaaS tools are first thing deployed because HR, finance, and operations teams don't need IT setup. They just log in and start working. Simple explanation. SaaS is like staying in a hotel. Everything is already ready, bed, food, cleaning. You just check in and start using. Final comparison, story summary moment. So now let's connect everything from real IT experience. IaaS, you build everything full control, IT engineers. PaaS, you build apps only, developers focus. SaaS, you just use software, end users. Closing impact line, engagement boost. So in real IT projects, the biggest skill is not just knowing these terms. It is understanding which model to choose in which business situation. And that decision is what makes you a strong cloud engineer in the industry.
Azure Global Infrastructure. Let me ask you a question. Have you ever wondered how you can watch a Netflix movie, send a WhatsApp message, attend a Teams meeting, or access your company's applications from anywhere in the world? And everything works within seconds? Behind that speed and reliability is a massive global infrastructure. And today we're going to understand how Microsoft Azure makes that possible. Don't worry about technical terms. By the end of this slide, you'll understand it using a simple real-world example. Imagine Microsoft is running a global delivery company. Let's imagine Microsoft Azure is a giant delivery company serving customers around the world. If customers live in India, America, Europe, Australia, and Japan, would it make sense to have only one warehouse in the entire world? Of course not. Deliveries would be slow, expensive, and unreliable. So Microsoft builds infrastructure across the world. And this brings us to our first concept: regions. A region is simply a geographical area where Microsoft provides cloud services. For example, Microsoft has regions in India, the United States, Europe, and many other countries. Real work example. Imagine your company has employees mainly in Hyderabad and Bangalore. If you host your application in India, employees can access it faster. But if the application is hosted in another continent, users may experience delays. So when cloud engineers deploy applications, one of the first questions they ask is, which Azure region should we choose? Simple memory trick. Think of a region as a city where Microsoft has a major presence. Data centers. Now inside every region there are data centers. A data center is a physical building filled with thousands of servers, storage devices, networking equipment, cooling systems, and backup power. Real-work example. When you create a virtual machine in Azure, it is actually running on a server inside one of these data centers. You may never see the server physically, but it exists somewhere inside a Microsoft facility. Simple memory trick. If a region is a city, then a data center is a building inside that city. Availability zones. Now let's imagine something happens. A power outage affects one data center. Should your application stop working? Absolutely not. This is where availability zones help. Availability zones are separate data centers within the same region. If one zone experiences a problem, another zone continues running your application. Real-work example. In banking systems, online shopping platforms, and healthcare applications, downtime can cost thousands of dollars. So organizations deploy applications across multiple availability zones. Even if one data center fails, customers continue using the service without noticing any interruption. Simple memory trick. Availability zones are backup buildings in the same city. Region pairs. Now let's think bigger. What if an entire region experiences a major disaster? Maybe a natural disaster, large-scale power issue, or network outage. This is where region pairs come into the picture. Microsoft pairs regions together. If one region becomes unavailable, data and services can be recovered from the paired region. Real-work example. Many companies replicate important business data to another Azure region. This ensures business continuity even during major incidents. Simple memory trick. Region pairs are like having a backup city ready if your main city becomes unavailable. Satellite antenna edge locations. Now let's talk about speed. Users don't like waiting. If a website takes 5 seconds to load, many users leave immediately. So Microsoft places edge locations closer to users. These locations store frequently used content such as images, videos, and website files. Real-work example. When an employee downloads a company training video, it may come from a nearby edge location rather than a distant data center. This improves performance significantly. Simple memory trick. Think of edge locations as local delivery centers close to customers. Global network. Now imagine connecting every region, every data center, every availability zone, and every edge location. How does Microsoft do that? Using its global network. This is Microsoft's private high-speed network that connects infrastructure across the world. Real-work example. When data travels between Azure regions, it doesn't always travel over the public internet. It often travels through Microsoft's secure private backbone network. This improves security, speed, and reliability. Simple memory trick. Global network is the superhighway connecting all Azure locations worldwide. Final summary. So let's quickly recap everything. Region equals a city where Azure services are available. Data center equals a building containing servers. Availability zone equals backup data centers inside the same region. Region pair equals backup region for disaster recovery. Edge location equals local delivery center for faster content access. Global network equals Microsoft's private highway connecting everything. Closing statement. The reason millions of businesses trust Azure is not just because of servers. It's because Microsoft has built a global infrastructure designed for speed, reliability, security, and business continuity. And as future cloud professionals, understanding this foundation will help you understand every Azure service that we learn from this point onward. Now that we understand where Azure runs, let's move to the next topic and see how these cloud services are actually delivered to customers. Azure Architecture. Let me start with a real workplace situation. Imagine you have joined a company as an IT administrator. Your manager comes to you and says, "We are moving our applications to Azure. We need proper organization, cost tracking, and easy management." Now imagine if hundreds of servers, databases, storage accounts, and networks were created without any structure. Very soon nobody would know which resources belong to which project, who is paying for them, which team owns them, how much they are costing. This is exactly why Azure Architecture is important. Today we'll understand Azure Architecture using a simple company example. Subscriptions. Let's start with subscriptions. Think of a subscription as a separate billing account. Imagine your company has 3 departments: finance, human resources, sales. Each department has its own budget. The company wants to know exactly how much each department spends on cloud resources. So instead of putting everything together, they create separate Azure subscriptions. One subscription for finance, one for HR, one for sales. Now the company can easily track costs and manage budgets. In real projects, this is very common. Large organizations often have multiple subscriptions for different departments, environments, or customers. Simply remember, a subscription helps organize resources and control costs. Resource groups. Now let's go one level deeper. Inside a subscription, we create resource groups. Think of a resource group as a project folder. Imagine your company is launching a new employee portal application. This application requires a virtual machine, database, storage, networking components. Instead of creating everything randomly, you place all related resources into one resource group. Now whenever you want to manage, update, or delete the project, everything is grouped together. In real workplaces, resource groups make administration much easier. If a project is retired, administrators can remove the entire resource group instead of finding resources one by one. Simply remember, resource groups are containers that hold related resources. Resources. Now let's talk about resources. Resources are the actual services you create in Azure. Examples include virtual machines, storage accounts, databases, virtual networks, load balancers, web applications. Think of resources as the actual equipment inside your office. The building is there. The rooms are there. But the desks, laptops, printers, and networking devices are what people actually use. Similarly, resources are the actual cloud services that perform the work. In my experience, most daily Azure administration revolves around managing resources, creating them, monitoring them, updating them, securing them, and optimizing their costs. Management. Now imagine your company has hundreds of Azure resources. How do you control everything? How do you ensure users only access what they need? How do you track costs? How do you maintain security? This is where Azure Management comes in. Management includes monitoring, access control, policies, cost management, security controls. For example, a junior support engineer may only have permission to restart virtual machines, but only senior administrators can delete them. This helps prevent accidental mistakes. In real organizations, management is one of the most important responsibilities of cloud administrators. Because creating resources is easy, managing them properly is what keeps the environment secure and organized. Organization. Let's put everything together. Imagine Azure as a company office. At the top is the subscription. Inside the subscription are resource groups. Inside resource groups are resources. This structure helps organizations stay organized as they grow. Without organization, cloud environments quickly become difficult to manage. I've seen environments where resources were created without naming standards or proper grouping. After a few years, nobody knew what belonged to which application. That creates confusion, security risks, and unnecessary costs. Good organization solves these problems. Best practices. Now let's look at some best practices used in real companies. First, use meaningful names. Instead of naming a server Server 1, use names that clearly identify its purpose. Second, separate production and testing environments. You don't want developers accidentally affecting live business applications. Third, use resource groups wisely. Keep resources belonging to the same application together. Fourth, monitor costs regularly. Cloud services are easy to create, but costs can increase quickly if resources are left running unnecessarily. Finally, follow the principle of least privilege. Give users only the permissions they need to do their jobs. Nothing more. Nothing less. Closing summary. Let's quickly recap. A subscription helps manage billing and ownership. Resource groups organize related resources together. Resources are the actual Azure services being used. Management helps control security, monitoring, and access. Organization keeps everything structured and easy to maintain. Best practices help companies reduce costs, improve security, and simplify administration. When you understand this structure, Azure becomes much easier to manage because every resource has a place, every team has ownership, and every cost can be tracked. And that is the foundation of Azure architecture used in real-world organizations every day. Azure Portal. Let me ask you a simple question. Imagine it's Monday morning. You arrive at work, open your laptop, and receive 3 requests at the same time. One user says, "My application is down." Another user says, "I need a new virtual machine." And your manager asks, "Can you check yesterday's cloud costs and resource health?" Now imagine trying to do all of this without a central management console. It would be difficult. This is exactly why Microsoft created the Azure Portal. The Azure Portal is the main place where administrators, engineers, and support teams manage Azure services. Think of it as the control room for your entire cloud environment. Today, let's see how it helps us manage Azure resources in the real world. Dashboard. The first thing you see after logging into Azure is the dashboard. Think of the dashboard as the cockpit of an airplane. Pilot needs to see important information immediately. Similarly, an Azure administrator needs quick access to important cloud information. The dashboard can display virtual machines, storage accounts, alerts, cost information, resource health, recent activities, real workplace example. When I start my day as an administrator, I don't want to search for everything manually. I want to immediately know, are any servers down? Are there any alerts? Is anything consuming unusual resources? The dashboard gives that information in one place. Simply remember, the dashboard is your personalized cloud homepage. Resource creation. Now let's imagine a new project starts. The development team says, "We need a server for testing." As an administrator, you don't buy hardware anymore. Instead, you open Azure Portal and create resources within minutes. You can create virtual machines, storage accounts, databases, virtual networks, web applications, and many other services. Real workplace example. Years ago, creating a server could take days or even weeks because hardware had to be purchased and installed. With Azure Portal, a virtual machine can be deployed in just a few minutes. This is one of the biggest advantages of cloud computing. Simply remember, Azure Portal allows you to create cloud resources quickly and easily. Monitoring. Now let's say the application is running. Can we simply forget about it? Course not. Applications must be monitored continuously. This is where monitoring becomes important. Azure Portal helps administrators track CPU usage, memory utilization, network activity, application performance, alerts and warnings. Real workplace example. Imagine a company's customer portal suddenly becomes slow. Instead of guessing the problem, administrators can use monitoring tools to identify whether the server is overloaded, the database is slow, the network is experiencing issues. Monitoring helps find problems before users start complaining. Simply remember, monitoring helps keep systems healthy and available. Search. Now imagine your company has hundreds or even thousands of Azure resources. Finding a specific virtual machine manually would be frustrating. This is where search becomes extremely useful. Azure Portal includes a powerful search feature. You can quickly find virtual machines, storage accounts, resource groups, users, networks, policies, and almost anything else in Azure. Real workplace example. In large organizations, Administrators rarely browse through menus. Most of the time they simply type the resource name into the search bar and access it instantly. This saves valuable time. Simply remember, search helps you find resources quickly in large environments. Cloud Shell. Now let's talk about one of my favorite tools in Azure Portal. Cloud Shell. Cloud Shell is a browser-based command line environment. It allows administrators to manage Azure using commands without installing tools on their computers. Real workplace example. Imagine you're working remotely on someone else's computer. You need to perform Azure administration tasks. Instead of installing software, you open Azure Portal and launch Cloud Shell. Immediately you can run commands and manage resources. Many experienced administrators use Cloud Shell because it is fast and efficient. Simply remember, Cloud Shell gives you command line access directly from the browser. Administration. Now let's bring everything together. Administration is where Azure Portal becomes truly powerful. Administrators use Azure Portal to manage users, assign permissions, control access, monitor security, track costs, configure policies, manage resources. Real workplace example. Suppose a new employee joins the company. The administrator may create access permissions, assign resources, grant application access, configure security settings, all from Azure Portal. Similarly, when an employee leaves the company, access can be removed immediately. This helps maintain security and compliance. Simply remember, Azure Portal is the central management platform for the entire Azure environment. Closing summary. Let's quickly review what we learned. Dashboard gives a quick view of important cloud information. Resource creation allows us to deploy services quickly. Monitoring helps us track performance and identify issues. Search helps us locate resources instantly. Cloud Shell provides command line management directly from the browser. Administration allows us to manage users, security, permissions, and resources. If Azure were a city, the Azure Portal would be the control center where everything is managed, monitored, and controlled. And for anyone working in cloud, support, administration, or engineering, Azure Portal is one of the most important tools you will use every day. In the next section, we'll continue exploring how Azure services work together to build modern cloud solutions. Azure Resource Manager. Let me start with a simple workplace story. Imagine you work in an IT team. One day, your manager comes to you and says, "We need 5 identical environments for our development team. Each environment needs a virtual machine, a storage account, a network, security settings, and monitoring configured exactly the same way." Now imagine creating all of that manually 5 different times. You might forget a setting. You might give the wrong name. You might configure one environment differently from the others. And suddenly, troubleshooting becomes a nightmare. This is exactly the problem Azure Resource Manager helps solve. Today we're going to understand how Azure Resource Manager makes cloud management faster, easier, and more consistent. What is Azure Resource Manager? Think of Azure Resource Manager, or ARM, as the project manager of Azure. Instead of creating and managing resources individually, ARM organizes and controls everything for you. Whenever you create a virtual machine, storage account, or network through Azure, ARM is working behind the scenes. Its job is to ensure resources are created correctly and managed consistently. Templates. Let's begin with templates. Imagine a builder constructing multiple houses. Would the builder start from scratch every time? Probably not. They would use a blueprint. A blueprint ensures every house is built the same way. ARM templates work exactly like that blueprint. Instead of manually creating resources every time, we create a template that defines the server, the network, the storage, the settings. Once the template is ready, Azure can build the environment automatically. Real workplace example. Suppose your company opens a new branch office. Instead of manually creating infrastructure again, administrators can use an ARM template to deploy the same environment in minutes. This saves time and reduces mistakes. Simply remember, templates are blueprints for Azure resources. Deployments. Now let's talk about deployments. A deployment is the process of creating resources using a template. Think about ordering a custom-built laptop online. You choose the specifications. Then the manufacturer assembles everything based on your requirements. Similarly, ARM reads the template and automatically creates the resources. Real workplace example. In many organizations, development teams need test environments regularly. Instead of waiting for IT administrators to manually build everything, deployments create environments automatically. What once took hours can now take minutes. Simply remember, templates are the instructions. Deployments are the actual execution. Automation. Now imagine performing the same task every day. Creating servers. Assigning settings. Configuring resources. Repeating these steps manually becomes boring and increases the chance of mistakes. This is where automation becomes valuable. ARM allows Azure to perform repetitive tasks automatically. Real workplace example. Suppose your company creates a new testing environment every month. Instead of building it manually each time, automation performs the entire process. The administrator simply starts the process, and Azure does the rest. This improves speed, accuracy, and productivity. Simply remember, automation reduces manual work and saves time. Tagging. Now let's imagine your company has hundreds of Azure resources. After a few months, someone asks, which resources belong to the finance team? Which resources are used for the HR application? Without organization, finding the answer becomes difficult. This is where tagging helps. Tags are labels attached to Azure resources. Examples might include department equals finance, environment equals production, project equals employee portal, owner equals a team. Real workplace example. During cost reviews, managers often want to know how much each department is spending in Azure. Tags make it easy to generate reports and identify ownership. Simply remember, tags are labels that help organize resources. Governance. Now let's talk about governance. Imagine a company where employees can buy anything they want without approval. Very quickly, costs would increase and standards would disappear. Cloud environments face the same challenge. Governance ensures resources follow company rules. For example, only approved locations can be used. Only approved resource types can be created. Naming standards must be followed. Security policies must be applied. Real workplace example. Many organizations prevent employees from creating resources in unauthorized regions. This helps control costs, security, and compliance requirements. Simply remember, governance helps organizations stay secure, compliant, and organized. Consistency. Now let's bring everything together. One of the biggest goals in cloud computing is consistency. If 10 administrators create the same environment, the result should be identical every time. Without consistency, one server may have different settings. Another may have different security rules. Troubleshooting becomes difficult. With ARM templates and automation, Azure creates resources the same way every time. Real workplace example. In enterprise environments, production servers often need identical configurations. Consistency ensures applications behave predictably regardless of who deployed them. Simply remember, consistency means getting the same reliable result every time. Closing summary. Let's quickly recap. Templates provide the blueprint. Deployments create the resources. Automation reduces manual effort. Tagging helps organize and track resources. Governance enforces company rules. Consistency ensures environments are built the same way every time. Think of Azure Resource Manager as the project manager that keeps everything organized, controlled, and predictable. Without ARM, managing cloud resources would be complicated and time-consuming. With ARM, organizations can deploy faster, work smarter, and maintain high standards across their entire Azure environment. And that's why Azure Resource Manager is one of the most important foundations of modern cloud administration. Azure Compute Overview. Let me start with a real-world situation. Imagine your company has just launched a new online shopping website. Everything is working perfectly. Customers are placing orders. Sales are increasing. And suddenly, festival sale starts. Thousands of customers visit the website at the same time. The IT team starts receiving calls. The website is slow. Pages are not loading. Customers cannot place orders. Now the business is losing money every minute. The big question is, how do we provide enough computing power to handle this demand? This is where Azure Compute Services help. Azure offers different compute options depending on what the business needs. Today, we'll understand the most important Azure Compute Services using simple workplace examples. Virtual machines, VMs. Let's start with virtual machines. A virtual machine is simply a computer running inside Azure. Just like your office laptop has an operating system, GPU, memory, storage. An Azure virtual machine has the same components. The difference is that it runs in Microsoft's cloud instead of sitting under your desk. Real workplace example. Imagine your company has an old application that works only on Windows Server. The developers don't want to redesign the application. The easiest solution is to create a virtual machine in Azure and install the application there. This is very common during cloud migrations. Companies move existing servers into Azure virtual machines without changing the application. Simply remember, a VM is like renting a computer in the cloud. Tailset. Now let's imagine the online shopping website becomes very popular. One server is no longer enough. More customers arrive every minute. Instead of manually creating servers whenever traffic increases, Azure can do it automatically. This is called virtual machine scale sets. Real workplace example. During a major sale event, website traffic may increase 10 times. Azure automatically adds more virtual machines to handle the load. When traffic decreases, Azure removes the extra machines. The company only pays for what it uses. Simply remember, scale sets automatically increase or decrease servers based on demand. Containers. Now let's look at containers. Imagine developers create an application on their laptop. It works perfectly. But when the application is moved to another server, it suddenly stops working. Different software versions, different settings, different dependencies. Containers solve this problem. They package the application and everything it needs into a single unit. Real workplace example. Developers can create an application once and run it anywhere. Whether it's a laptop, test environment, or production server, the application behaves the same way. This makes deployments faster and more reliable. Simply remember, a container is a portable package containing an application and everything it needs. Services. Now imagine your company only wants to host a website. They don't want to manage servers. They don't want to install operating systems. They don't want to worry about updates. They simply want to upload their website and make it available to users. This is where Azure App Services help. Real workplace example. A development team builds a company portal. Instead of creating virtual machines, they deploy the website directly to app services. Azure manages the infrastructure behind the scenes. The team focuses on developing the application rather than managing servers. Simply remember, app services allow you to host web applications without managing servers. Functions. Now let's imagine a different situation. Company receives thousands of files every day. Whenever a file is uploaded, a small process needs to run automatically. For example, sending notifications, updating a database, processing images. Instead of running a full server all day, Azure Functions execute code only when needed. Real workplace example. An employee uploads a document. Azure automatically triggers a function. The function validates the file and stores information in a database. The entire process happens automatically. And the company only pays when the code runs. Simply remember, functions run small pieces of code when specific events occur. Azure Kubernetes Service, AKS. Now let's imagine the company grows even bigger. Instead of one application, there are dozens of applications running inside containers. Managing all these containers manually becomes difficult. This is where Azure Kubernetes Service, or AKS, comes in. AKS helps manage large numbers of containers efficiently. Real workplace example. Large companies often run hundreds or even thousands of containers. AKS automatically handles deployment, scaling, monitoring, recovery, load balancing. This allows organizations to run modern applications at large scale. Simply remember, AKS helps manage and organize containers automatically. Bringing it all together. Let's go back to our online shopping company. If they need a traditional server, they use virtual machines. If traffic changes frequently, they use scale sets. If developers want portable applications, they use containers. If they only want to host a website, they use app services. If they need event-driven automation, they use functions. If they manage large numbers of containers, they use AKS. Each service solves a different business problem. Closing summary. Let's quickly review. Virtual machines provide cloud-based computers. Scale sets automatically add or remove virtual machines based on demand. Containers package applications for consistent deployment. App services host websites and applications without server management. Functions run code only when triggered. AKS manages containers at scale. The most important thing to remember is this. Azure Compute is not about choosing the most powerful service. It's about choosing the right service for the business requirement. And that is exactly how cloud engineers make decisions in real-world organizations every day. Azure Virtual Machines. Let me start with a real workplace story. Imagine your company has an important business application running on a server in the office. One day the server suddenly fails. Employees cannot access the application. Managers start calling. Customers are affected. The IT team is under pressure to restore services quickly. Now imagine, instead of relying on physical hardware in the office, you could create a new server in the cloud within minutes. That is exactly what Azure Virtual Machines provide. Azure Virtual Machines allow organizations to run servers in the cloud without buying physical hardware. Today, let's understand Azure Virtual Machines using simple real-world examples. What is a virtual machine? Think of a virtual machine as a computer running inside Microsoft's data center. Just like your office computer, it has an operating system, GPU, memory, storage, networking. The difference is that you access it through the cloud. You don't need to buy hardware, install servers in a rack, or maintain a data center. Azure provides the infrastructure while you use the server. Real workplace example. When a development team needs a test server urgently, administrators can create a virtual machine in Azure within a few minutes instead of waiting days for new hardware. Simply remember, a virtual machine is a cloud-based computer. VM sizes. Now let's imagine you are buying a vehicle. Would you buy a large truck to deliver one small package? Probably not. Similarly, not every application needs a powerful server. Azure provides different VM sizes based on workload requirements. Some VMs are designed for small workloads, development environments, testing. Others are designed for large databases, business applications, high-performance computing. Real workplace example. A small internal application used by 10 employees may need only a small VM. But a banking application serving thousands of users may require a much larger VM with more CPU and memory. The goal is to choose the right size based on business needs. Simply remember, VM size determines the power and performance of the virtual machine. Now let's talk about storage. Every server needs a place to store operating systems, applications, files, databases. In Azure, this storage is provided through disks. Think of disks as the hard drives of the virtual machine. Real workplace example. Imagine an HR application storing employee records. The application runs on the VM, but employee data is stored on disks attached to the VM. The faster the disk, the faster the application can access data. For business-critical applications, organizations often choose high-performance disks to improve speed. Simply remember, disks store the data used by the virtual machine. Availability sets. Now let's imagine something unexpected happens. A physical server in the data center experiences a hardware issue. If your application depends on only one VM, users may lose access. This is where availability sets help. Availability sets distribute virtual machines across different hardware within the data center. If one server experiences a problem, another VM continues running. Real workplace example. Suppose an online employee portal is accessed by thousands of users daily. Instead of running one VM, administrators deploy multiple VMs in an availability set. This improves uptime and reduces the risk of service interruptions. Simply remember, availability sets help keep applications available even when hardware problems occur. Extensions. Now imagine you buy a new computer. After turning it on, you install antivirus software, monitoring tools, backup agents, management tools. Azure virtual machines work the same way. Extensions allow administrators to add extra functionality to a VM. Real workplace example. A company may install monitoring extensions on all VMs to track performance and detect issues automatically. This helps administrators identify problems before users are affected. Extensions save time because many tasks can be automated. Simply remember, extensions add additional features and capabilities to virtual machines. Use cases. Now let's talk about where virtual machines are actually used. Many organizations use VMs for hosting business applications, running databases, testing software, development environments, migrating existing servers to the cloud, disaster recovery solutions. Real workplace example. A company moving from an on-premises data center to Azure often starts by migrating existing servers into virtual machines. This allows them to move to the cloud without redesigning applications immediately. This approach is very common in real-world cloud projects. Simply remember, virtual machines are ideal when organizations need flexibility and full control. Administration. Now let's imagine your company has hundreds of virtual machines. Someone has to manage them. Administrators perform tasks such as starting and stopping VMs, monitoring performance, applying updates, managing security, configuring backups, controlling access. Real workplace example. An administrator may stop unused development VMs after office hours to reduce cloud costs. This simple action can save organizations a significant amount of money over time. Good administration is not just about keeping servers running. It is also about security, performance, and cost optimization. Simply remember, administration keeps virtual machines secure, healthy, and cost-effective. Closing summary. Let's quickly review. A virtual machine is a cloud-based server. VM sizes determine how much CPU and memory the VM receives. Disks provide storage for applications and data. Availability sets improve uptime and reliability. Extensions add additional functionality to VMs. Use cases include hosting applications, testing, development, and migration. Administration ensures VMs remain secure, optimized, and properly managed. When most people think about cloud computing, they often think about virtual machines first. Because even though cloud technology continues to evolve, virtual machines remain one of the most widely used and important services in Azure. And understanding them gives you a strong foundation for learning many other Azure services. VM scale sets. Let me start with a real business situation. Imagine your company owns an online shopping website. Most days, around 500 people visit the website. Everything works perfectly. Then a festival sale starts. Suddenly, 50,000 customers try to access the website at the same time. The website becomes slow. Customers cannot place orders. The business starts losing money. Now imagine hiring additional employees only during busy hours and sending them home when business becomes normal again. Wouldn't that be efficient? That is exactly how VM scale sets work in Azure. They automatically add more virtual machines when demand increases and remove them when demand decreases. Today, let's understand VM scale sets using simple workplace examples. What are VM scale sets? Think of VM scale sets as a team of identical servers working together. Instead of running one virtual machine, Azure can create multiple virtual machines automatically. As demand increases, more VMs are added. As demand decreases, extra VMs are removed. The goal is simple. Keep applications running smoothly without wasting money. Real workplace example. Imagine an online banking application. During salary credit days, thousands of users log in simultaneously. Instead of administrators manually creating servers, VM scale sets automatically increase capacity. Users continue accessing services without delays. Simply remember, VM scale sets automatically adjust the number of virtual machines based on demand. Auto-scale. Now let's talk about the most important feature. Auto-scale. Imagine a shopping mall. During weekends, more staff members are needed. During weekdays, fewer staff members are required. Businesses adjust staffing based on customer traffic. VM scale sets do exactly the same thing. Azure monitors workload and automatically decides when to add or remove virtual machines. Real workplace example. Suppose your company website normally runs on 2 virtual machines. When CPU usage becomes high, Azure automatically increases the count to 5 or 10 virtual machines. When traffic decreases later, Azure reduces the number again. No manual intervention is required. Simply remember, auto-scale means Azure automatically adjusts resources based on workload. Load balancing. Now imagine 10 checkout counters in a supermarket. If everyone stands at one counter while the others remain empty, customers will wait longer. A manager would direct customers to different counters. Azure load balancing works the same way. It distributes incoming traffic across multiple virtual machines. Real workplace example. Suppose 10,000 users visit a company website. Instead of sending all requests to one VM, Azure spreads the traffic across multiple VMs. This improves performance and user experience. Simply remember, load balancing shares work across multiple servers. High availability. Now let's imagine one server suddenly fails. Hardware problems happen. Power issues happen. Unexpected failures happen. Should users lose access to the application? Course not. VM scale sets provide high availability by running multiple instances. If one VM becomes unavailable, others continue serving users. Real workplace example. Many organizations run critical applications such as payroll systems, customer portals, and e-commerce websites. Even if one VM fails, users continue working because other VMs remain available. This minimizes downtime. Simply remember, high availability helps applications remain accessible even during failures. Monitoring. Now imagine driving a car without a dashboard. You wouldn't know your speed, fuel level, engine condition. Similarly, administrators need visibility into VM performance. Azure Monitoring provides information about CPU usage, memory utilization, network traffic, application health, alerts. Real workplace example. Suppose CPU usage suddenly rises above normal levels. Monitoring detects the issue and can even trigger autoscale to add more VMs automatically. This helps prevent performance problems before users notice them. Simply remember, monitoring helps administrators understand system health and performance. Dates. Now let's think about software updates. Imagine managing 50 servers manually. Installing updates one by one would take a lot of time. VM scale sets help simplify updates across multiple virtual machines. Azure can update machines in a controlled manner while keeping services available. Real workplace example. Company needs to apply security updates to all servers. Instead of shutting everything down at once, updates are performed gradually. Users continue accessing the application while updates are completed. This improves security without causing major disruptions. Simply remember, VM scale sets help manage updates efficiently across many servers. Cost efficiency. Now let's talk about something every manager loves. Saving money. Imagine renting 10 office buildings even though you only need 2. That would be a waste of money. Similarly, running extra servers when nobody is using them increases cloud costs. VM scale sets help control expenses by automatically removing unnecessary resources. Real workplace example. A company receives heavy traffic during business hours. At night, traffic drops significantly. Azure reduces the number of virtual machines automatically. The company pays only for the resources it actually uses. This is one of the biggest advantages of cloud computing. Simply remember, cost efficiency means using only the resources you need and avoiding unnecessary expenses. Closing summary. Let's quickly review. VM scale sets manage multiple identical virtual machines. Autoscale automatically adds or removes VMs based on workload. Load balancing distributes traffic across servers. High availability keeps applications running during failures. Monitoring helps track performance and health. Updates can be applied efficiently across many virtual machines. Cost efficiency helps organizations reduce cloud spending. Think of VM scale sets as a smart workforce. When business grows, more workers join automatically. When business slows down, extra workers leave. The result is better performance, higher availability, and lower costs. And that's why VM scale sets are widely used for modern applications running in Azure. Azure App Service. Let me start with a simple workplace story. Imagine your company's development team has just completed a new employee self-service portal. Employees will use it to apply for leave, view payslips, update personal information, raise IT requests. Now the application is ready. The developers come to the IT team and ask, "Can you make this application available to all employees?" A few years ago you would have needed to build a server, install Windows, configure AS, set up networking, manage updates, configure security. This could take hours or even days. Today, Azure provides a much easier solution called Azure App Service. With App Service, developers can focus on the application while Azure manages most of the infrastructure. Let's see how it works. What is Azure App Service? Think of Azure App Service as a ready-to-use platform for hosting applications. Instead of worrying about servers and operating systems, you simply deploy your application and Azure handles the rest. Real workplace example. Imagine your company launches a new internal portal. The development team uploads the application to Azure App Service. Within minutes, employees can access the website from anywhere. No server installation. No operating system configuration. No hardware management. Simply remember, Azure App Service allows you to host applications without managing servers. Web apps. Let's start with web apps. Web apps are used to host websites and web applications. Real workplace example. Think about a company intranet. Employees use it every day to access policies, submit requests, read company announcements. Instead of maintaining dedicated servers, the company hosts the portal using Azure Web Apps. The IT team spends less time managing infrastructure and more time supporting business needs. Simply remember, web apps are used to host websites and web-based applications. PI apps. Now imagine the company's mobile application needs data from a back-end system. For example, employee details, leave balances, ticket information. The mobile app needs a secure way to communicate with company systems. This is where API apps help. APIs allow different applications to exchange information. Real workplace example. Suppose an employee opens a mobile app and checks their leave balance. The mobile app sends a request to an API. The API retrieves information from the database and returns the result. Everything happens within seconds. Simply remember, API apps allow applications to communicate and share data securely. Deployment slots. Now let's imagine the development team creates a new version of the employee portal. The question is, How do we update the application without affecting users? Deployment slots solve this problem. Think of deployment slots as a testing area. Developers can deploy the new version and test it before making it live. Real workplace example. Version 1 of the application is currently being used by employees. The developers deploy version 2 to a separate slot. After testing is completed, the new version is swapped into production. Employees receive the updated application with minimal interruption. This greatly reduces deployment risk. Simply remember, deployment slots allow safe testing before releasing updates to users. Scaling. Now imagine the company launches an important event. Thousands of employees access the portal at the same time. Traffic suddenly increases. If the application cannot handle the load, users will experience delays. Azure App Service provides scaling. Azure can automatically increase resources when demand rises. Real workplace example. During annual performance reviews, employees may access HR applications simultaneously. Azure automatically adds capacity to support the increased traffic. Once demand decreases, resources are reduced again. This ensures good performance without wasting money. Simply remember, scaling allows applications to handle changing workloads automatically. Security. Now let's talk about something every organization cares about. Security. A company portal may contain employee information, business data, internal documents. Protecting this information is critical. Azure App Service includes several security capabilities. Real workplace example. Employees can sign in using their company accounts. Administrators can control who has access. Data can be encrypted while moving across the network. Security settings can be managed centrally. This helps organizations protect sensitive information. Simply remember, security features help keep applications and data protected. Use cases. Now let's look at where Azure App Service is commonly used. Organizations use App Service for company websites, employee portals, customer portals, business applications, REST APIs, mobile application backends, internal business tools. Real workplace example. A company may host its public website, its HR portal, its customer support application, and its mobile application backend, all using Azure App Service. This reduces complexity and simplifies management. Simply remember, App Service is ideal for organizations that want to focus on applications instead of infrastructure. Closing summary. Let's quickly review. Azure App Service provides a platform for hosting applications without managing servers. Web apps host websites and web applications. API apps allow systems and applications to communicate. Deployment slots enable safe application updates. Scaling automatically adjusts resources based on demand. Security features help protect applications and business data. Use cases include websites, portals, APIs, and business applications. The biggest advantage of Azure App Service is simple. Developers focus on building applications. Azure handles much of the infrastructure management, and that allows organizations to deliver applications faster, more securely, and with less operational effort. That is why Azure App Service is one of the most popular services used in modern cloud environments. Azure Functions. Let me start with a simple workplace story. Imagine you work in an IT department. Every day, employees upload documents to a company portal. Whenever a document is uploaded, someone needs to check the file, store information in a database, send a notification email, create an audit record. Now imagine keeping a server running 24 hours a day just for these small tasks. Most of the time, that server would be doing absolutely nothing. Yet the company would still be paying for it. Wouldn't it be better if the code ran only when needed? That is exactly what Azure Functions does. Azure Functions is one of the smartest services in Azure because it runs code only when an event occurs. Let's see how it works. What is Azure Functions? Think of Azure Functions as an employee who only works when a task arrives. If there is no work, the employee doesn't consume company resources. The moment work arrives, the employee starts working automatically. Azure Functions works the same way. The code runs only when triggered. When the work is finished, Azure stops using resources. Real workplace example. Suppose an employee uploads a file. Azure Functions automatically processes the file. After the task is complete, the function stops running. No server management. No idle resources. Simply remember, Azure Functions runs code only when it is needed. Serverless. Now let's talk about the word serverless. Many people hear serverless and think there are no servers. That is not true. Servers still exist. Microsoft manages them for you. The difference is that you don't need to worry about operating systems, server maintenance, dates, infrastructure management. Real workplace example. In traditional environments, administrators create and maintain servers. With Azure Functions, developers simply write code and Azure handles the infrastructure automatically. This saves a lot of time and effort. Simply remember, serverless means you focus on code while Azure manages the servers. Triggers. Now let's imagine a doorbell. When someone presses the doorbell, a specific action happens. Azure Functions works in a similar way using triggers. A trigger is an event that starts the function. Real workplace examples. File is uploaded. An email arrives. A database record changes. Scheduled time occurs. A user submits a form. Each of these events can automatically start an Azure function. For example, an employee uploads a document. The upload event triggers the function. The function processes the file automatically. Simply remember, a trigger is the event that starts the function. Bindings. Now imagine delivering a package. Without a delivery service, you would manually transport the package yourself. Bindings make Azure Functions easier by automatically connecting the function to other Azure services. Real workplace example. A function receives data from a storage account, processes the information, stores results in a database. Without writing a lot of connection code, Azure handles much of the communication automatically. This reduces development effort and simplifies integration. Simply remember, bindings help Azure Functions connect to other services easily. Automation. Now let's talk about something every IT team loves. Automation. Imagine performing the same task hundreds of times every week. Checking files, sending notifications, updating records, generating reports. These repetitive activities consume valuable time. Azure Functions can automate them. Real workplace example. Suppose HR receives employee onboarding forms. Whenever a form is submitted, a user account is created. A welcome email is sent. The employee record is updated. All of this can happen automatically using Azure Functions. No manual intervention required. Simply remember, automation allows routine tasks to run automatically. Cost savings. Now let's talk about money. Imagine hiring a full-time employee who works only 5 minutes per day. That wouldn't be cost-effective. Traditional servers often run continuously even when there is no work. Azure Functions follows a different model. You pay only when the function runs. Real workplace example. A function may run for only a few seconds whenever a file is uploaded. The company pays only for those few seconds of execution. If no files are uploaded, there is little or no compute cost. This makes Azure Functions very cost-efficient for event-driven workloads. Simply remember, Azure Functions helps reduce costs because resources are used only when needed. Examples. Now let's look at some common real-world examples. Organizations use Azure Functions for processing uploaded files, sending notifications, generating reports, automating workflows, updating databases, managing IoT device data, creating scheduled tasks, integrating business applications. Real workplace example. Imagine a company receives invoices from suppliers. As soon as an invoice is uploaded, the function extracts information. stores the data in a database, sends a notification to the finance team. The entire process happens automatically. This improves speed and reduces manual effort. Simply remember, Azure Functions is ideal for small tasks that need to happen automatically when events occur. Closing summary. Let's quickly review. Azure Functions is a serverless compute service. Serverless means Azure manages the infrastructure. Triggers start functions when events occur. Bindings simplify connections with other services. Automation reduces repetitive manual work. Cost savings come from paying only when code runs. Common examples include file processing, notifications, reporting, and workflow automation. The biggest advantage of Azure Functions is simple. You don't need to keep a server running all day for small tasks. Your code runs only when required. This saves time, reduces costs, and allows organizations to automate business processes efficiently. And that is why Azure Functions is one of the most powerful services in modern cloud environments. Containers and AKS. Let me start with a real workplace situation. Imagine you are working in a software company as a cloud engineer. Your development team says, "Our application works perfectly on my laptop." But when they move it to the test server, breaks, some features fail, some services don't start, and the support team gets involved again and again. Now the question is, why does this happen? Because the application behaves differently in different environments. This is exactly the problem containers solve. And when containers grow at scale, we use Kubernetes and Azure Kubernetes Service. Let's understand this in a simple real-world way. Docker. Let's start with Docker. Think of Docker as a packing system. Imagine you are sending a gift box. Instead of sending items separately, you pack everything into one box. Application, dependencies, libraries, configuration. Everything needed to run the application is inside one package. That is exactly what Docker does. Real workplace example. A developer builds an application on Windows laptop. Another server runs Linux. Without Docker, the application may break due to environment differences. But with Docker, the application runs the same everywhere because everything is packaged. Simply remember, Docker packages an application so it runs consistently anywhere. Containers. Now let's understand containers in simple terms. A container is the running instance of a Docker image. Think of it like this. Docker creates the box. Container is the running box in action. Real workplace example. A company builds a web application. They package it using Docker. Now they can run multiple copies of the same application. For testing, for production, for scaling. All running consistently without conflicts. Simply remember, containers make applications portable and consistent. Kubernetes. Now imagine your company is no longer running just one or two containers. You are running hundreds of containers. Some handle login. Some handle payments. Some handle notifications. Managing all of them manually becomes very difficult. This is where Kubernetes comes in. Kubernetes is a container orchestration system. It manages containers automatically. Real workplace example. In a large e-commerce company, if one container fails, Kubernetes restarts it. If traffic increases, Kubernetes creates more containers. If traffic decreases, Kubernetes removes extra containers. Everything is automated. Simply remember, Kubernetes manages and controls containers automatically. KS. Azure Kubernetes Service. Now let's bring Kubernetes into Azure. Instead of installing and managing Kubernetes manually, Azure provides a managed service called AKS. That is Azure Kubernetes Service. Azure Kubernetes Service. Real workplace example. In a real company, setting up Kubernetes from scratch requires servers, networking setup, cluster configuration, maintenance, dates, security management. But with AKS, Azure handles most of this. Engineers simply deploy applications. Simply remember, KS is Kubernetes managed by Azure. Microservices. Now let's understand microservices. In traditional applications, everything is built as one big system. Login, payments, notifications, user management, all combined. If one part fails, the entire application can break. Microservices solve this problem. They break applications into small independent services. Real workplace example. An e-commerce application is divided into login service, payment service, order service, notification service. Each service runs independently. If payment service fails, users can still browse products. Simply remember, microservices break applications into small independent services. Scaling. Now let's talk about scaling. Imagine your website suddenly gets a huge number of users. If only one container is running, it will get overloaded. With containers and Kubernetes, scaling becomes automatic. Real workplace example. During a flash sale, traffic increases 10x. Kubernetes automatically creates more containers. When traffic drops, extra containers are removed. This ensures performance and cost control. Simply remember, scaling means increasing or decreasing resources based on demand. Management. Now let's talk about management. When you have many containers running across multiple applications, you need proper management. TES helps manage deployments, dates, health monitoring, load balancing, security policies. Real workplace example. In a real enterprise setup, instead of managing each container manually, engineers manage everything through AKS dashboards and commands. If something fails, Kubernetes automatically fixes it. Simply remember, KS simplifies large-scale container management. Closing summary. Let's quickly recap. Docker packages applications with everything they need. Containers are running instances of those packages. Kubernetes manages and controls containers at scale. KS is Azure's managed Kubernetes service. Microservices break applications into small independent services. Scaling ensures performance adjusts based on demand. Management becomes easier through automation and orchestration. The key idea is simple. Instead of building one big application, modern cloud systems are built using small containers that are easy to deploy, scale, and manage. And that is why containers and AKS are widely used in modern cloud-native applications today. Azure Networking. Let me start with a real workplace situation. Imagine you are working as a cloud engineer in a company. The company has multiple applications: HR portal, finance system, employee login system, customer application. Now the manager says, all these applications must be secure, fast, and able to communicate with each other safely. But there is one challenge. These applications are running in different parts of the cloud. Now the question is, how do we connect everything securely? This is where Azure Networking comes in. Virtual Network, VNet. Let's start with Virtual Network, also called VNet. Think of VNet as a private network inside Azure. It is like your own secure office building in the cloud. Only authorized systems inside that network can communicate with each other. Real workplace example. Imagine your company building a private campus. Only employees inside the campus can access internal systems. Similarly, VNet creates a private space in Azure for your applications. Simply remember, VNet is a private network in the cloud. Subnet. Now let's go one level deeper. Inside a VNet we create subnets. Think of a subnet as dividing a large office building into departments. For example, HR department, finance department, IT department. Each department has its own space but still belongs to the same building. Real workplace example. In a company network, web servers may be placed in one subnet. Databases may be placed in another subnet. This improves security and organization. Simply remember, subnet divides a network into smaller sections. Routing. Now let's talk about routing. Routing is how data travels from one place to another. Think of it like road directions in a city. When you want to go somewhere, GPS tells you the correct route. Similarly, Routing ensures data reaches the correct destination in Azure. Real workplace example. A user requests data from a web application. Routing ensures the request goes to the correct server and returns the response properly. Without routing, data would not know where to go. Simply remember, routing controls how data moves in a network. DNS. Now let's understand DNS. DNS stands for Domain Name System. Think of it as the phone book of the Internet. Instead of remembering IP addresses like 192.168.1.1, we use names like company.com. DNS converts names into IP addresses. Real workplace example. When an employee opens a company website, DNS automatically finds the correct server address. The user simply types a name, not numbers. Simply remember, DNS converts names into IP addresses. Peering. Now let's imagine your company has multiple virtual networks. One for HR, one for finance, one for development. Now these networks need to communicate securely. This is where VNet peering comes in. Peering connects two virtual networks so they can talk to each other privately. Real workplace example. HR system needs employee data from finance system. Instead of using the public internet, both networks are connected using VNet peering. This makes communication faster and more secure. Simply remember, peering connects virtual networks securely inside Azure. Connectivity. Now let's talk about connectivity. Connectivity means how different networks, users, and systems connect to Azure. Azure supports multiple types of connectivity. Site-to-site VPN, point-to-site VPN, ExpressRoute, Internet access. Real workplace example. Employees working from home connect to company resources using VPN. Large organizations use private connections like ExpressRoute for better speed and security. Simply remember, connectivity enables users and systems to access Azure securely. Bringing everything together. Let's connect everything like a real IT environment. VNet creates a private network. Subnet organizes that network into sections. Routing controls traffic flow. DNS helps locate services using names. Peering connects multiple networks. Connectivity allows users to access everything securely. Closing summary. Let's quickly recap. Virtual network creates a secure private cloud network. Subnets divide networks into smaller sections. Routing manages how data moves. DNS converts names into IP addresses. Peering connects multiple virtual networks. Connectivity enables secure access from users and systems. The key idea is simple. Azure Networking is the foundation that allows applications, users, and services to communicate securely and efficiently across the cloud. Without networking, cloud applications cannot function. And that is why understanding Azure Networking is essential for every cloud engineer. Network Security Groups, NSG. Let me start with a real workplace situation. Imagine you are working as a cloud engineer in a company. You deployed a web application in Azure. Everything is working fine. But suddenly users report. The website is not opening. You check the server. It is running fine. CPU is normal. Memory is fine. But still users cannot access it. Now the question is, if everything is working, why is access blocked? This is where network security groups come into the picture. What is an NSG? Think of a network security group as a security guard for your network. It decides who can enter and who can leave. Every request to a virtual machine or subnet must pass through the security check. Real workplace example. Imagine your office building has a security gate. Even if the building is open, no one can enter without permission. Similarly, NSG controls network traffic in Azure. Simply remember, NSG is a security filter for network traffic. Inbound rules. Now let's talk about inbound rules. Inbound rules control traffic coming into your system. Think of it as people entering your office. Only authorized people are allowed inside. Real workplace example. If a web server is hosted in Azure, users must be allowed to access it through port 80 or 443. So an inbound rule allows HTTP and HTTPS traffic. Without this rule, Users cannot access the website even if the server is running. Simply remember. Inbound rules control incoming traffic. Outbound rules. Now let's talk about outbound rules. Outbound rules control traffic leaving your system. Think of it as employees leaving the office or sending emails outside. Real workplace example. A virtual machine may need to connect to external services like dates, PIs, databases in another region. Outbound rules decide whether this communication is allowed. Simply remember. Outbound rules control outgoing traffic. Priorities. Now let's understand priorities. NSG rules are not checked randomly. They follow a priority order. Lower number means higher priority. So the rule with priority 100 is checked before 200. Real workplace example. Imagine security guards with instructions. A VIP rule is always checked first before normal rules. If a match is found, other rules are ignored. Simply remember. Priority decides which rule is applied first. Security. Now let's talk about the main purpose of NSG. Security. NSGs protect resources from unauthorized access. They ensure only allowed traffic can reach your servers. Real workplace example. In banking systems, only specific IP addresses are allowed to access sensitive servers. All other traffic is blocked automatically. This prevents attacks and unauthorized access. Simply remember. NSG is a security layer for network protection. Examples. Now let's look at simple examples. Example 1. Allow HTTP traffic on port 80 for a web server. Example 2. Allow HTTPS traffic on port 443. Example 3. Block all traffic except from company IP addresses. Example 4. Allow database access only from application servers. Real workplace example. In enterprise environments, web servers are open to users. Database servers are restricted and only accessible internally. This layered security is very common. Simply remember. NSGs use rules to allow or deny network traffic. Troubleshooting. Now let's talk about real-world troubleshooting. This is where most engineers get confused. If a user cannot access an application, NSG is one of the first things to check. Real workplace example. A user says, "Application is not reachable." Steps an engineer follows. Check if NSG is attached to VM or subnet. Verify inbound rules for correct ports. Check priority conflicts. Ensure source IP is allowed. Check outbound rules if external access is needed. Most issues are resolved by correcting NSG rules. Simply remember. NSG troubleshooting is about checking rules, ports, and priorities. Closing summary. Let's quickly recap. Network security groups act like a security guard for Azure networks. Inbound rules control incoming traffic. Outbound rules control outgoing traffic. Priorities decide which rule is applied first. Security ensures only authorized access is allowed. Examples include allowing web traffic and blocking unauthorized access. Troubleshooting involves checking rules, ports, and access paths. The key idea is simple. NSGs protect your Azure resources by controlling network traffic in a smart and rule-based way. Without NSGs, cloud environments would be open and insecure. And that is why NSGs are one of the most important security components in Azure networking. Azure Load Balancer. Let me start with a real workplace situation. Imagine you are working as a cloud engineer in an e-commerce company. It's a big sale day. Thousands of users are visiting the website at the same time. Everything works fine at the beginning. But suddenly users start complaining. The website is slow. Pages are not loading. Login is failing. Now when you check, the application is running. But only one server is handling all the traffic. That server is overloaded. So the real problem is not the application. The problem is traffic distribution. This is exactly where Azure Load Balancer comes in. What is Load Balancer? Think of a load balancer as a smart traffic controller. It sits in front of your servers and distributes incoming requests evenly across multiple machines. Instead of one server handling everything, the load balancer shares the workload. Real workplace example. Imagine a supermarket with multiple billing counters. If all customers go to one counter, it becomes slow. A manager redirects customers to different counters to keep things fast. That is exactly what load balancer does. Simply remember, load balancer distributes traffic across multiple servers. Traffic distribution. Now let's understand traffic distribution. Traffic distribution means spreading user requests across multiple backend servers. This ensures no single server becomes overloaded. Real workplace example. When 10,000 users access a website, load balancer sends some users to server 1, some users to server 2, some users to server 3. All servers work together to handle the load. This improves performance and user experience. Simply remember, traffic distribution balances workload across servers. High availability, J. Now let's talk about high availability. High availability means your application should always be available, even if something fails. If one server goes down, another should immediately take over. Real workplace example. Imagine a banking application. If one server fails during login, users should still be able to access the system without interruption. Load balancer ensures this by redirecting traffic to healthy servers. Simply remember, high availability means the system stays available even during failures. Backend pools. Now let's understand backend pools. Backend pool is a group of servers that receive traffic from the load balancer. Think of it as a team of workers handling tasks together. Real workplace example. Company website runs on multiple virtual machines. All these VMs are added to a backend pool. Load balancer sends traffic only to these healthy machines. Simply remember, backend pool is a group of servers that handle traffic. Health probes. Now let's talk about health probes. Health probes are like health checkups for your servers. They continuously check whether a server is working properly or not. If a server is unhealthy, it is removed from traffic automatically. Real workplace example. If a virtual machine stops responding, load balancer detects it using health probes, stops sending traffic to that VM, redirects users to healthy servers. This happens automatically without human intervention. Simply remember, health probes check if servers are healthy or not. Public load balancer. Now let's understand public load balancer. A public load balancer is used when users access applications from the internet. It distributes internet traffic to backend servers. Real workplace example. A public website like an online shopping portal uses a public load balancer. Customers from anywhere in the world can access the application. Simply remember, public load balancer handles internet-facing traffic. Private load balancer. Now let's talk about private load balancer. Private load balancer is used inside a virtual network. It is not accessible from the internet. Real workplace example. Company's internal HR system is used only by employees. Does not need public access. So traffic is distributed internally using a private load balancer. Simply remember, private load balancer handles internal traffic within a network. Closing summary. Let's quickly recap. Azure Load Balancer distributes traffic across multiple servers. Traffic distribution ensures no single server is overloaded. High availability keeps applications running even if a server fails. Backend pools are groups of servers that handle requests. Health probes monitor server health continuously. Public load balancer handles internet traffic. Private load balancer handles internal network traffic. The key idea is simple. Load balancer ensures applications are fast, reliable, and always available. Without it, one server could become overloaded and the entire system could slow down or fail. And that is why Azure Load Balancer is a critical component in modern cloud architecture. VPN Gateway. Let me start with a real workplace situation. Imagine you are working as a cloud engineer in a company that has two environments. One is the on-premises Office data center. The other is Microsoft Azure Cloud. Now the company says, our employees should be able to securely access Azure applications from Office and from home. But there is a challenge. The Office network and Azure network are completely separate. They cannot talk to each other by default. So the question is, how do we securely connect on-premises and cloud networks? This is where VPN Gateway comes in. What is VPN Gateway? Think of VPN Gateway as a secure tunnel between two networks. Instead of exposing data to the public internet, it creates an encrypted private connection. This allows safe communication between Office networks, cloud networks, and remote users. Real workplace example. Imagine a secure underground tunnel between two buildings. Only authorized employees can use it. No outsiders can access it. That is exactly how VPN Gateway works. Simply remember, VPN Gateway creates a secure connection between networks. Site-to-site VPN. Now let's talk about site-to-site VPN. Site-to-site VPN connects an entire on-premises network to Azure. It is used when an organization wants full network connectivity between Office and cloud. Real workplace example. A company has its main Office data center in Hyderabad. It also has applications running in Azure. Instead of accessing Azure manually, the entire Office network is connected to Azure using a VPN device. Now all systems can communicate as if they are in the same network. Simply remember, site-to-site VPN connects Office network to Azure network. Point-to-site VPN. Now let's talk about point-to-site VPN. Point-to-site VPN is used for individual users. It allows a single device to connect securely to Azure. Real workplace example. An employee is working from home. They need to access company resources in Azure. Instead of connecting the entire office, only their laptop connects securely using VPN software. Simply remember, point-to-site VPN connects a single user device to Azure. Remote access. Now let's understand remote access. Remote access means employees can securely connect to company resources from anywhere. This is very important in modern hybrid workplaces. Real workplace example. An IT engineer is traveling. They need to access servers in Azure to troubleshoot an issue. Using VPN, they can securely connect and manage systems from anywhere in the world. Simply remember, remote access allows users to work from anywhere securely. Hybrid cloud. Now let's talk about hybrid cloud. Hybrid cloud means a combination of on-premises infrastructure and cloud services working together. VPN Gateway is a key enabler of hybrid cloud. Real workplace example. A company keeps sensitive data in its local data center, but runs applications in Azure for scalability. VPN Gateway connects both environments so they work together seamlessly. Simply remember, hybrid cloud connects on-premises systems with cloud systems. Encryption. Now let's talk about encryption. Encryption means protecting data by converting it into a secure format while it travels across networks. VPN Gateway automatically encrypts traffic between networks. Real workplace example. When data travels from Office to Azure, it is encrypted. It cannot be read by unauthorized users. Even if intercepted, it is useless without decryption keys. This ensures strong security for enterprise communication. Simply remember, encryption protects data during transmission. Connectivity. Now let's understand connectivity. Connectivity means enabling communication between users, networks, and cloud resources. VPN Gateway provides secure connectivity across Office networks, Azure networks, remote users. Real workplace example. Employees in Office access Azure applications directly through VPN connection. Remote users connect securely from home. Cloud and on-premises systems communicate without interruption. Simply remember, VPN Gateway enables secure connectivity between different environments. Closing summary. Let's quickly recap. VPN Gateway creates a secure tunnel between networks. Site-to-site VPN connects entire Office networks to Azure. Point-to-site VPN connects individual users to Azure. Remote access allows users to connect from anywhere. Hybrid cloud combines on-premises and cloud environments. Encryption protects data during transmission. Connectivity enables secure communication between all systems. The key idea is simple. VPN Gateway ensures secure, encrypted communication between on-premises networks, Azure Cloud, and remote users. Without VPN Gateway, hybrid cloud environments would not be secure or properly connected. And that is why VPN Gateway is a critical component in modern enterprise cloud architecture. ExpressRoute. Let me start with a real workplace situation. Imagine you are working as a cloud engineer in a large enterprise company like a bank or telecom organization. The company already has a big on-premises data center. Now they are moving critical applications to Microsoft Azure. Everything is going well. But suddenly the security team raises a concern. We cannot send sensitive data over the public internet. Now the challenge becomes very serious. Because the company needs cloud connectivity. But it must be secure, fast, reliable, and private. This is exactly where ExpressRoute comes in. What is ExpressRoute? Think of ExpressRoute as a private highway between your office data center and Microsoft Azure. Unlike VPN, which uses the public internet, ExpressRoute does not use the internet at all. Creates a dedicated private connection. Real workplace example. Imagine a company building its own exclusive road between two offices. Only company traffic is allowed. No public vehicles. No congestion. No internet exposure. That is exactly what ExpressRoute does. Simply remember. ExpressRoute provides private connectivity between on-premises and Azure. Private connectivity. Now let's talk about private connectivity. Private connectivity means your data does not travel over the public internet. Instead, it travels through a dedicated private circuit. Real workplace example. A banking organization transfers customer transaction data. They cannot risk sending it over the public internet. So they use ExpressRoute to ensure the data travels through a secure private network. Simply remember. Private connectivity means secure communication without using the internet. Performance. Now let's talk about performance. Since ExpressRoute does not use the internet, there is no public network congestion. So performance is much faster and more stable. Real workplace example. A company running real-time trading applications needs low latency. Even milliseconds matter. ExpressRoute ensures stable and high-speed connectivity between systems. Simply remember. ExpressRoute provides high performance with low latency. Reliability. Now let's understand reliability. Reliability means the connection is stable and always available. ExpressRoute offers higher reliability compared to internet-based connections. Real workplace example. In VPN connections, internet issues can cause disconnections. But in ExpressRoute, dedicated circuits ensure consistent connectivity. This is critical for enterprise applications. Simply remember. ExpressRoute provides consistent and reliable connectivity. Hybrid cloud. Now let's talk about hybrid cloud. Hybrid cloud means combining on-premises systems with cloud systems. ExpressRoute is a key technology for enabling hybrid cloud architecture. Real workplace example. A company keeps sensitive databases in its local data center, but runs applications in Azure. ExpressRoute connects both environments securely and efficiently. This allows smooth data flow between on-prem and cloud. Simply remember. ExpressRoute enables seamless hybrid cloud connectivity. Security. Now let's talk about security. Security is one of the biggest advantages of ExpressRoute. Since traffic does not travel over the public internet, it reduces exposure to threats. Real workplace example. In financial institutions, customer data is highly sensitive. ExpressRoute ensures that data flows through a private network, reducing risk of attacks or interception. Simply remember. ExpressRoute provides secure, private data transfer. Use cases. Now let's look at real-world use cases. Organizations use ExpressRoute for banking applications, large enterprise systems, data migration to Azure, real-time analytics, Disaster recovery setups. Hybrid cloud connectivity. Real workplace example. A large company migrating terabytes of data from on-premises storage to Azure uses ExpressRoute to ensure fast and secure transfer without depending on the internet. Simply remember, ExpressRoute is used for enterprise-grade, secure, high-speed cloud connectivity. Closing summary. Let's quickly recap. ExpressRoute provides private connectivity between on-premises and Azure. Private connectivity ensures data does not use the public internet. Performance is faster and more stable. Reliability ensures consistent connectivity. Hybrid cloud enables seamless integration between on-prem and cloud. Security protects sensitive enterprise data. Use cases include banking, migration, analytics, and enterprise applications. The key idea is simple. ExpressRoute is the premium enterprise-level connection to Azure. It is used when organizations need maximum security, performance, and reliability. And that is why ExpressRoute is widely used in large-scale cloud architectures. Azure Storage. Let me start with a simple workplace story. Imagine you join a company on Monday morning. Your manager asks, "We have employee documents, application logs, customer images, backup files, and business data. We need a place to store everything safely in Azure." Now think about your office. Would you keep employee files, customer records, courier packages, and company documents all in the same drawer? Probably not. You would organize them based on their purpose. Azure Storage works in a very similar way. Provides different storage services for different business needs. Today, let's understand Azure Storage using simple real-world examples. Storage accounts. Let's start with storage accounts. Think of a storage account as a large digital warehouse. Before storing anything in Azure, you first create a storage account. Inside this account, you can store different types of data. Real workplace example. Imagine your company rents a warehouse. Once the warehouse is available, different sections can be used for documents, packages, records, and inventory. Similarly, a storage account is the foundation that holds all Azure storage services. Simply remember, a storage account is the main container that holds Azure storage services. Blob Storage. Now let's talk about Blob Storage. Blob Storage is used for storing unstructured data. Examples include images, videos, documents, backup, application files. Real workplace example. Imagine your company's website allows customers to upload profile pictures. Where are those images stored? Typically in Blob Storage. Another example is CCTV recordings, training videos, or application backups. All of these are ideal for Blob Storage. Simply remember, Blob Storage is used for storing files like images, videos, and documents. File storage. Now imagine your office has a shared folder. Employees save documents and everyone can access them. Azure File Storage works in a similar way. It provides shared file storage that multiple users or servers can access. Real workplace example. A company may have a shared folder called HR Documents. Employees access it from different systems. Instead of maintaining a file server in the office, the company stores files in Azure File Storage. This simplifies management and improves accessibility. Simply remember, file storage provides shared folders in the cloud. Queue storage. Now let's look at queue storage. Think about a customer service desk. Customers take a token and wait for their turn. Requests are processed one by one. Queue storage works the same way. It temporarily stores messages until an application processes them. Real workplace example. Imagine an online shopping website. Customer places an order. The order details are placed into a queue. Another application processes the order and updates inventory. This prevents systems from becoming overloaded. Simply remember, queue storage stores messages waiting to be processed. Table storage. Now let's talk about table storage. Table storage is used for storing structured data. Think of it as storing information in rows and columns. Real workplace example. Suppose an application stores employee information. Employee ID, name, department, Location. This type of structured information can be stored in table storage. It is useful when applications need fast access to large amounts of data. Simply remember, table storage stores structured data efficiently. Redundancy. Now let's discuss one of the most important concepts in Azure Storage. Redundancy. Imagine you save an important company document on a single laptop. If the laptop fails, the document could be lost. That would be a disaster. Azure avoids this problem through redundancy. Redundancy means Azure creates multiple copies of your data. Real workplace example. Suppose your company stores critical customer records in Azure. Azure automatically keeps additional copies of that data. If one storage location experiences a problem, another copy remains available. This helps protect business data from hardware failures and outages. Simply remember, redundancy means Azure stores multiple copies of your data for protection and availability. Bringing everything together. Let's connect everything using a real company example. A company creates a storage account. Employee documents are stored in file storage. Customer images are stored in Blob Storage. Order requests are stored in queue storage. Business records are stored in table storage. Redundancy ensures all data remains protected. Everything is organized, accessible, and secure. Closing summary. Let's quickly review. Storage account is the foundation for Azure Storage services. Blob Storage stores images, videos, backups, and files. File storage provides shared folders. Queue storage stores messages waiting for processing. Table storage stores structured application data. Redundancy protects data by creating multiple copies. The key idea is simple. Azure Storage is not just one storage service. It is a collection of storage options designed for different business requirements. And choosing the right storage type helps organizations improve performance, reduce costs, and protect valuable business data. That is why Azure Storage is one of the most widely used services in Azure. Azure Blob Storage. Let me start with a real workplace situation. Imagine you are working in a company that runs an online video platform. Users upload training videos, product demos, marketing content, old recordings. Some videos are watched every day. Some are rarely accessed. And some are only needed for compliance or backup. Now the question is, do all these files need the same level of storage performance? Of course not. Some data must be fast and frequently accessible. Some data must be stored cheaply for long-term use. This is exactly where Azure Blob Storage tiers come in. What is Blob Storage? Before we go into tiers, let's quickly understand Blob Storage. Think of Blob Storage as a digital storage system for unstructured data like images, videos, documents, backup, log files. Real workplace example. A company stores employee profile pictures, training videos, and system backups in Blob Storage. It is flexible, scalable, and widely used in real applications. Simply remember, Blob Storage stores files like images, videos, and backups in the cloud. Hot tier. Now let's start with the hot tier. Think of the hot tier as the front shelf in a supermarket. Items placed here are used frequently and need to be accessed quickly. Real workplace example. A company's website stores profile pictures and active documents in the hot tier because users access them daily. This tier provides fast access, higher storage cost, optimized for frequently used data. Simply remember, hot tier is for frequently accessed data. Cool tier. Now let's move to the cool tier. Think of this as a storage room in the back of the office. Data is not used daily, but still needed occasionally. Real workplace example. A company stores old project files or older customer data that is accessed once in a few months. Cool tier provides lower storage costs than hot tier, moderate access speed, best for infrequently accessed data. Simply remember, cool tier is for less frequently accessed data. Archive tier. Now let's talk about the archive tier. Think of this as a deep storage vault. You don't access it regularly. You store data just for long-term retention. Real workplace example. A company keeps old financial records or compliance logs that are rarely accessed but must be stored for legal reasons. Archive tier provides very low-cost storage, very slow retrieval. Data must be rehydrated before access. Simply remember, archive tier is for rarely accessed long-term data. Lifecycle management. Now imagine manually moving files between hot, cool, and archive tiers. That would be time-consuming. This is where lifecycle management helps. It automatically moves data between tiers based on rules. Real workplace example. A company sets a rule. New files stay in hot tier for 30 days. After 30 days, move to cool tier. After 180 days, move to archive tier. Azure automatically manages this without human effort. Simply remember, lifecycle rules automatically manage data movement between tiers. Backup. Now let's talk about backups. Backups are copies of important data kept for recovery purposes. If something goes wrong, data can be restored. Real workplace example. A company accidentally deletes important files. Instead of losing data, they restore it from Azure Blob Backups. Backups protect against accidental deletion, system failure, data corruption. Simply remember, backups ensure data can be restored when needed. Security. Now let's talk about security. Security in Blob Storage ensures that only authorized users can access data. Real workplace example. A company stores confidential employee data in Blob Storage. Only HR team members are allowed to access it. Security features include access control, encryption, authentication, role-based permissions. Even if someone tries to access the data without permission, they are blocked. Simply remember, security protects data from unauthorized access. Bringing it all together, let's connect everything. Hot tier is used for frequently accessed data. Cool tier is for rarely accessed but still needed data. Archive tier is for long-term storage with minimal access. Lifecycle management automates data movement between tiers. Backups protect data from loss. Security ensures only authorized users can access data. Closing summary. Let's quickly recap. Blob storage is used for storing unstructured data like files, images, and videos. Hot tier is for active and frequently used data. Cool tier is for infrequently accessed data. Archive tier is for long-term, rarely accessed data. Lifecycle management automates storage optimization. Backups protect critical data. Security ensures data protection and access control. The key idea is simple. Azure Blob Storage is not just storage. It is an intelligent system that helps organizations balance performance, cost, and security based on how data is used. And that is why Blob Storage is one of the most important services in Azure for modern cloud workloads. Azure Files. Let me start with a real workplace situation. Imagine you are working in an IT support team. One morning, users start calling. I cannot access shared company folders. My documents are missing from the shared drive. The team folder is not syncing. Now you check the environment. Everything is running fine. The applications are working. But users cannot access shared files. The problem is not the application. The problem is file sharing. This is where Azure Files becomes very useful. What is Azure Files? Think of Azure Files as a cloud-based shared drive. It works just like the file server in your office, but it is hosted in Azure. Users can store, access, and share files from anywhere. Real workplace example. In a traditional office, companies use a Windows file server for shared folders like HR documents, project files, company policies. Azure Files replaces that server with a cloud-based solution. Simply remember, Azure Files provides shared file storage in the cloud. SMB access. Now let's talk about SMB access. SMB stands for Server Message Block. It is a protocol used to access shared folders over a network. In simple terms, it allows your computer to connect to a shared drive. Real workplace example. When employees map a network drive like Z Drive in office systems, They are using SMB. With Azure Files, the same experience is available in the cloud. Users can map network drives, open shared folders, work on files directly from Azure. Simply remember, SMB access allows Azure Files to behave like a traditional shared network drive. Migration. Now let's talk about migration. Many companies already have file servers on premises. Moving those files to the cloud is called migration. Azure Files makes this transition simple. Real workplace example. A company has 10 years of shared documents stored on a local file server. Instead of rebuilding everything, they migrate the entire file structure to Azure Files. This reduces hardware dependency, maintenance effort, data center costs. Simply remember, migration means moving existing file servers to Azure Files. Hybrid. Now let's understand hybrid usage. Hybrid means using both on-premises and cloud together. Azure Files supports hybrid scenarios very well. Real workplace example. A company still uses local file servers but also wants cloud access. With Azure Files, employees in office access local files. Remote users access the same files from Azure. Both environments stay connected and synchronized. Simply remember, hybrid means combining on-premises file servers with Azure Files. Permissions. Now let's talk about permissions. Permissions control who can access files and what they can do. In Azure Files you can define read access, write access, full control. Real workplace example. In a company, HR team can access employee records. Finance team can access financial files. Other employees cannot access restricted folders. This ensures data security and proper access control. Simply remember, permissions control access to files and folders. Backup. Now let's talk about backups. Backup means keeping a safe copy of your files in case something goes wrong. Real workplace example. An employee accidentally deletes an important project folder. Instead of losing data permanently, IT restores it from Azure File Backup. Backups protect against accidental deletion, ransomware attacks, system failures. Simply remember, backups ensure file recovery when needed. Use cases. Now let's look at real-world use cases. Azure Files is commonly used for shared company folders, application file storage, home directories for users, lift and shift migrations, backup storage, hybrid file access. Real workplace example. A company moves its legacy application to Azure, but the application still needs shared file storage. Instead of redesigning the system, they simply connect it to Azure Files. This makes migration easier and faster. Simply remember, Azure Files is used whenever shared file access is needed in cloud or hybrid environments. Closing summary. Let's quickly recap. Azure Files provides cloud-based shared file storage. SMB access allows it to work like a traditional network drive. Migration helps move existing file servers to Azure. Hybrid support allows both on-prem and cloud access. Permissions control user access and security. Backup protects against data loss. Use cases include shared folders, migrations, and application storage. The key idea is simple. Azure Files brings traditional file server experience into the cloud with better scalability, accessibility, and reliability. And that is why it is widely used in enterprise environments that are moving from on-premises to Azure. Azure Databases. Let me start with a real workplace situation. Imagine you are working as a cloud engineer in a company that runs an online banking application. Every second, users log in. Transactions are processed. Account balances are updated. Reports are generated. Now think about this. Where is all this data stored? How is it managed safely, securely, and at scale? This is where Azure Databases come in. Azure provides multiple database options depending on the type of application and data. Today, let's understand them in a simple real-world way. What are Azure Databases? Think of databases as the brain of an application. They store user information, transactions, business records, Application data. Real workplace example. When you check your bank balance on a mobile app, the data is fetched from a database in the backend. Without databases, applications cannot function. Simply remember, databases store and manage application data. Azure SQL Database. Now let's start with Azure SQL Database. This is a fully managed relational database service. It is based on Microsoft SQL Server. Real workplace example. Company builds an HR application. It stores employee details like name, salary, department. Azure SQL Database manages this data securely and efficiently without requiring server management. Simply remember, Azure SQL is a managed relational database for structured data. Managed instance. Now let's talk about Azure SQL Managed Instance. Think of it as a more advanced version of Azure SQL Database. It is designed for organizations migrating full SQL Server environments to Azure. Real workplace example. A company already has a large SQL Server system on premises. Instead of rewriting applications, they move the entire database system to Azure Managed Instance. It behaves almost like a traditional SQL Server but runs in the cloud. Simply remember, Managed Instance helps lift and shift SQL Server workloads to Azure. Cosmos DB. Now let's talk about Cosmos DB. Cosmos DB is a NoSQL database designed for global-scale applications. It is extremely fast and highly scalable. Real workplace example. A global e-commerce company serves customers from different countries. They need low latency, fast data access, global distribution. Cosmos DB ensures users get data quickly no matter where they are in the world. Simply remember, Cosmos DB is a globally distributed NoSQL database. Azure MySQL. Now let's talk about Azure Database for MySQL. This is a managed version of the MySQL database engine. Real workplace example. A company builds a website using open-source technologies like PHP. It uses MySQL to store data such as user accounts, product information, orders. Azure manages the infrastructure while developers focus on the application. Simply remember, Azure MySQL is a managed open-source relational database. Azure PostgreSQL. Now let's talk about Azure Database for PostgreSQL. PostgreSQL is another open-source relational database. It is widely used for complex queries and analytics. Real workplace example. Company runs a data analytics platform, processes large datasets and generates reports. PostgreSQL is used because it handles complex queries efficiently. Simply remember, Azure PostgreSQL is a powerful open-source relational database for advanced workloads. Selection criteria. Now let's talk about how to choose the right database. This is very important in real-world projects. You don't select a database randomly. You choose based on application needs. Real workplace decision guide. If your data is structured and traditional, use Azure SQL Database. If you are migrating existing SQL Server, use Managed Instance. If you need global scale and fast NoSQL, use Cosmos DB. If you are using open-source MySQL applications, use Azure MySQL. If you need advanced analytics and complex queries, use PostgreSQL. Simply remember, database selection depends on application requirements, not personal preference. Bringing it all together, let's connect everything. Azure SQL is for structured enterprise applications. Managed Instance is for migrating existing SQL Server systems. Cosmos DB is for global high-speed applications. MySQL is for open-source web applications. PostgreSQL is for complex analytics and data processing. Each database solves a different business problem. Closing summary. Let's quickly recap. Azure Databases store and manage application data. Azure SQL is used for structured relational data. Managed Instance helps migrate existing SQL Server systems. Cosmos DB supports global-scale NoSQL applications. MySQL is used for open-source applications. PostgreSQL is used for advanced analytics and queries. Selection depends on workload type and business needs. The key idea is simple. There is no single best database in Azure. There is only the right database for the right application. And that is why understanding Azure database options is very important for cloud engineers and architects in real-world environments. Azure SQL Database. Let me start with a real workplace situation. Imagine you are working in an IT team of a growing company. The company has an HR application where employees can view their salary slips, apply for leave, check attendance, date personal details. One morning, the HR team reports. The application is slow during login. Users are getting delays while fetching data. Now you check the system. The application is fine. The server is running. But the database is struggling to handle the load. This is where Azure SQL Database becomes very important. What is Azure SQL Database? Think of Azure SQL Database as a fully managed database in the cloud. It is a platform as a service, PaaS, which means you don't manage servers. You don't install software. You don't handle patches or updates. Azure takes care of everything behind the scenes. Real workplace example. Instead of maintaining a physical SQL server in the office, companies simply create a database in Azure. Developers focus on applications. Azure manages infrastructure. Simply remember, Azure SQL Database is a fully managed cloud database service. PaaS database. Now let's understand what makes it a PaaS database. PaaS means platform as a service. In simple terms, Azure provides the platform. You only manage your data and application. Real workplace example. In traditional setups, key teams install SQL Server, configure hardware, manage backups, apply updates manually. In Azure SQL Database, all of this is handled automatically. This reduces effort and improves reliability. Simply remember, PaaS database means Azure manages infrastructure, you manage data. Backup. Now let's talk about backups. Backups are automatic copies of your data stored safely. They help recover data when something goes wrong. Real workplace example. Imagine an employee accidentally deletes important HR records. In a traditional system, recovery may take hours or even days. In Azure SQL Database, automatic backups are already enabled. You can restore data to a specific point in time. This protects business-critical information. Simply remember, Azure SQL provides automatic backups for data protection. Scaling. Now let's talk about scaling. Scaling means increasing or decreasing database resources based on demand. Real workplace example. During month-end payroll processing, thousands of employees access the HR system at the same time. Azure SQL Database automatically increases resources to handle the load. After the workload decreases, resources are reduced. This ensures performance and cost efficiency. Simply remember, Azure SQL scales automatically based on workload. Security. Now let's talk about security. Security in Azure SQL Database is very strong because it is built for enterprise workloads. It includes data encryption, access control, firewall rules, authentication mechanisms. Real workplace example. A finance application stores sensitive salary and tax data. Only authorized HR and finance users can access it. Even if someone tries to access it externally, they are blocked. Simply remember, Azure SQL protects data using strong security features. Monitoring. Now let's talk about monitoring. Monitoring helps track performance, health, and usage of the database. Real workplace example. An IT engineer notices the HR application is slowing down. Using Azure monitoring tools, they check CPU usage, query performance, database load, wait times. They quickly identify the problem and fix it before users are heavily impacted. Simply remember, monitoring helps detect and fix database performance issues. Use cases. Now let's look at real-world use cases. Azure SQL Database is commonly used for HR systems, finance applications, customer relationship management systems. web applications, commerce platforms, business reporting systems. Real workplace example. An online shopping website uses Azure SQL Database to store customer details, orders, payment records. It ensures fast and reliable access to data. Simply remember, Azure SQL is used for structured business applications. Bringing it all together, let's connect everything. Azure SQL Database is a fully managed PaaS database. Backups are automatic and protect data. Scaling adjusts performance based on demand. Security protects sensitive business information. Monitoring ensures smooth performance and early issue detection. Use cases include HR systems, finance apps, and web applications. Closing summary. Let's quickly recap. Azure SQL Database is a managed relational database service. It removes the need for manual server management, provides automatic backups for recovery, scales automatically for performance. It includes strong security features, provides monitoring tools for performance tracking. The key idea is simple. Azure SQL Database allows organizations to focus on applications and data, while Azure manages infrastructure, performance, and reliability. And that is why it is one of the most widely used database services in modern cloud environments. Azure Cosmos DB. Let me start with a real workplace situation. Imagine you are working for a global e-commerce company. Customers are accessing your application from India, USA, Europe, Australia. Now think about this. When a customer in India clicks, "Buy now," and a customer in the USA does the same, both expect the system to respond instantly. Not in seconds, not even in delays. They expect real-time response. Now the question is, how do you store and access data so fast across the world? This is where Azure Cosmos DB comes in. What is Cosmos DB? Think of Cosmos DB as a globally distributed database. It stores your data in multiple regions around the world, so users always access data from the nearest location. Real workplace example. If your application is deployed globally, a user in India gets data from the India region. A user in the USA gets data from the US region. A user in Europe gets data from Europe region. This reduces delay and improves performance. Simply remember, Cosmos DB is a globally distributed database for fast data access anywhere in the world. Global distribution. Now let's understand global distribution. Global distribution means your data is copied and available in multiple regions. Real workplace example. Company has customers in multiple countries. Instead of storing data in only one location, Cosmos DB replicates data across regions. So even if one region has issues, users can still access data from another region. Simply remember, global distribution means data is available across multiple locations worldwide. Multi-model. Now let's talk about multi-model support. Cosmos DB can store different types of data models in one system. It supports document data, key-value data, graph data, column family data. Real workplace example. An application may store customer profiles as documents, shopping cart data as key-value pairs, social connections as graphs, all inside one database system. This removes the need for multiple databases. Simply remember, Cosmos DB supports multiple data models in a single database. Low latency. Now let's talk about low latency. Latency means delay. Low latency means very fast response time. Real workplace example. In an online gaming application, even a small delay can affect user experience. Cosmos DB ensures data is retrieved almost instantly from the nearest region. This improves user experience significantly. Simply remember, Cosmos DB provides very fast data access with minimal delay. Scalability. Now let's understand scalability. Scalability means the system can handle increasing workloads without performance issues. Real workplace example. During a global sale event, millions of users access the application at the same time. Cosmos DB automatically handles this load without slowing down. Whether traffic is low or extremely high, performance remains consistent. Simply remember, Cosmos DB scales automatically for any level of traffic. Consistency. Now let's talk about consistency. Consistency ensures data is accurate and the same across all regions. Cosmos DB provides different consistency levels based on business needs. Real workplace example. In banking applications, account balance must always be accurate. Even if data is stored in multiple regions, it must stay consistent. Cosmos DB ensures users always see correct and synchronized data. Simply remember, consistency ensures accurate and reliable data across regions. Applications. Now let's look at real-world applications. Cosmos DB is commonly used in global e-commerce platforms, OT applications, gaming applications, social media platforms, real-time analytics systems. Real workplace example. Social media app stores, user profiles, posts, likes, comments. All of this data must be fast, globally available and scalable. Cosmos DB handles this perfectly. Simply remember, Cosmos DB is used for globally distributed high-performance applications. Bringing it all together, let's connect everything. Global distribution ensures worldwide access. Multi-model supports different types of data. Low latency ensures fast response times. Scalability handles any level of traffic. Consistency ensures accurate and reliable data. Applications include gaming, social media, IoT, and e-commerce systems. Closing summary. Let's quickly recap. Azure Cosmos DB is a globally distributed NoSQL database. It is designed for speed, scalability, and availability. It supports multiple data models in one system. It delivers low latency for users across the world. Scales automatically based on demand. It ensures data consistency across regions. The key idea is simple. Cosmos DB is built for modern applications that need global reach and real-time performance. And that is why it is widely used in large-scale high-performance cloud applications today. Microsoft Entra ID. Let me start with a real workplace situation. Imagine you are working in a company with 5,000 employees. Every day employees log into email, HR portal, payroll system, company applications, cloud tools like Azure and Microsoft 365. Now one morning the IT help desk gets flooded with calls. I forgot my password. I cannot access my application. I am getting permission denied. I need access to the system. Now think about this. How do you manage identities, passwords, and access for thousands of users in a secure and simple way? This is where Microsoft Entra ID comes in. What is Microsoft Entra ID? Think of Microsoft Entra ID as the digital identity system of an organization. It manages who the user is, how they sign in, what they can access. It is like the central identity control system for the cloud. Real workplace example. When an employee joins a company, IT creates a single identity for them. That one identity gives access to multiple applications. When they leave, access is removed from one place. Simply remember, Microsoft Entra ID manages identities and access in the cloud. Identity. Now let's understand identity. Identity means who the user is. It includes username, email, employee ID, group membership. Real workplace example. When you log into your company laptop, the system identifies you as a specific employee. That identity determines what systems you can access. Simply remember, identity is the digital representation of a user. Authentication. Now let's talk about authentication. Authentication means verifying who you are. It answers the question, are you really who you claim to be? Real workplace example. When you enter your password or use multi-factor authentication (OTP), the system verifies your identity. Only after successful authentication can you log in. Simply remember, authentication verifies user identity. Authorization. Now let's understand authorization. Authorization means what you are allowed to do after login. Real workplace example. Two employees log into the same system. HR employee can access salary details. Key employee can manage servers. Even though both are authenticated, their permissions are different. Simply remember, authorization controls access permissions after login. Single sign-on. Now let's talk about single sign-on. SSO allows users to log in once and access multiple applications without logging in again. Real workplace example. An employee logs into Microsoft 365. After that login, they can access Teams, Outlook, SharePoint, Azure Portal, without entering credentials again. This improves productivity and reduces password fatigue. Simply remember, SSO allows one login for multiple applications. Cloud identity. Now let's understand cloud identity. Cloud identity means user identities are managed in the cloud instead of on-premises servers. Real workplace example. Earlier, companies used local Active Directory servers. Now with Entra ID, identities are stored and managed in Azure Cloud. This allows users to access systems from anywhere. Simply remember, cloud identity means identity management is done in the cloud. Management. Now let's talk about management. Identity management includes creating users, assigning roles, managing groups, controlling access, removing users. Real workplace example. When a new employee joins, creates an account, assigns permissions, adds them to groups. When they leave, access is removed immediately. This improves security and control. Simply remember, identity management controls user lifecycle and access. Bringing it all together, let's connect everything. Identity defines who the user is. Authentication verifies the user. Authorization controls what they can access. SSO allows one login for multiple applications. Cloud identity stores users in Azure. Management handles user lifecycle and permissions. Closing summary. Let's quickly recap. Microsoft Entra ID is the identity and access management service in Azure. It ensures secure login and access control for users. It verifies identity through authentication. Controls permissions through authorization. It enables single sign-on for multiple applications. Provides cloud-based identity management. The key idea is simple. Microsoft Entra ID is the security gate of the cloud. Without it, managing users, access, and security in modern cloud environments would be impossible. And that is why it is one of the most critical services in Azure for every organization. Authentication methods. Let me start with a real workplace situation. Imagine you are working in an IT support team. It's Monday morning. And suddenly, your help desk is flooded with calls. I forgot my password. I am locked out of my account. I cannot log in to my email or Azure Portal. Now think about this. Every employee needs secure access to company systems. But at the same time, attackers are also trying to break in. So the question is, how do we make login both easy for users and secure for the organization? This is where authentication methods come in. What are authentication methods? Authentication methods are ways to verify a user's identity before allowing access. Think of it like different types of security checks at a building entrance. Some are simple, some are advanced, some are extremely secure. Let's go through them one by one in a simple real-world way. Passwords. Let's start with the most common one, passwords. Passwords are the traditional way of logging in. Real workplace example. An employee enters username, password. If both are correct, access is granted. But here is the problem. Passwords can be forgotten, stolen, reused across systems. This makes them the weakest form of authentication today. Simply remember, passwords are basic but not very secure. Multi-factor authentication, MFA. Now let's talk about MFA. MFA means using more than one method to verify identity. Real workplace example. You enter your password. Then the system sends an OTP to your mobile. Only after entering the OTP are you allowed in. Even if someone steals your password, they still cannot log in without your second factor. Simply remember, MFA adds an extra layer of security. Passwordless authentication. Now let's talk about passwordless login. Passwordless means you don't use a password at all. Instead you use fingerprint, face recognition, mobile approval, authenticator app. Real workplace example. An employee opens their laptop. They simply approve a notification on their phone. Or use fingerprint to log in. No password needed. This is faster and more secure. Simply remember. Passwordless means no password, only secure verification. Certificates. Now let's talk about certificates. Certificates are digital identity proofs stored on devices. They are more secure than passwords. Real workplace example. A company laptop has a digital certificate installed. When the device tries to access company resources, the system verifies the certificate automatically. No manual login is needed. This is commonly used in enterprise environments. Simply remember. Certificates provide secure device-based authentication. Security keys. Now let's understand security keys. Security keys are physical devices used for authentication. They are very secure because they require physical presence. Real workplace example. An employee carries a USB security key. To log in, they must plug it into the system and tap it. Even if someone knows the password, they cannot log in without the physical key. Simply remember. Security keys provide strong physical authentication. Best practices. Now let's talk about best practices. In real organizations, security is not just about one method. It is about combining methods properly. Real workplace best practices. Always enable MFA for all users. Avoid weak or reused passwords. Prefer passwordless authentication where possible. Use security keys for high-privilege accounts. Monitor login activity regularly. Apply conditional access policies. Real workplace example. In a finance company, employees use MFA for daily login. Administrators use security keys. External access is tightly controlled. This reduces the risk of attacks significantly. Simply remember. Best practices focus on strong layered security. Bringing it all together. Let's connect everything. Passwords are basic authentication. MFA adds an extra verification step. Passwordless removes passwords completely. Certificates provide device-based trust. Security keys provide physical authentication. Best practices combine all methods for maximum security. Closing summary. Let's quickly recap. Authentication methods are different ways to verify user identity. Passwords are simple but weak. MFA adds extra security. Passwordless improves speed and safety. Certificates provide device-level trust. Security keys provide strong physical protection. Best practices ensure strong and secure identity systems. The key idea is simple. Authentication is not just about logging in. It is about making sure the right person gets the right access at the right time securely. And that is why modern organizations are moving towards stronger, passwordless, and multi-factor authentication systems in the cloud. Role-based access control (RBAC). Let me start with a real workplace situation. Imagine you are working in a company that has moved everything to Azure. There are virtual machines, databases, storage accounts, web applications, hundreds of users accessing cloud resources every day. Now one morning, the IT manager gives a strict instruction. Everyone should only access what they need. Nothing more. Sounds simple. But in reality, this becomes one of the biggest challenges in any organization. Because if access is too open, it becomes a security risk. If access is too restricted, employees cannot do their job. So the question is, how do we control access in a smart and safe way? This is where role-based access control, or RBAC, comes in. What is RBAC? Think of RBAC as a permission system based on job roles. Instead of giving permissions to each individual manually, we assign permissions based on roles. Real workplace example. In a company, a manager needs full access. An HR employee needs access to employee data. An IT support engineer needs access to systems. A developer needs access to applications only. We don't assign permissions one by one. We assign roles, and roles define access. Simply remember, RBAC means access is controlled based on job roles. Roles. Let's start with roles. A role is a collection of permissions. Think of it as a job title with responsibilities. Real workplace example. A reader role can only view resources. A contributor role can create and modify resources. An owner role has full control over everything. Instead of giving 100 permissions manually, we simply assign a role. Simply remember, a role defines what a user is allowed to do. Assignments. Now let's talk about assignments. Assignments connect a user to a role. This is where the actual access is given. Real workplace example. A new employee joins the company. IT assigns them the contributor role for a specific project. Now they can manage resources for that project only. Without assignment, a role has no meaning. Simply remember, assignments link users to roles. Least privilege. Now let's talk about one of the most important security principles. Least privilege. Least privilege means giving only the minimum access required to perform a job. Not more, not less. Real workplace example. A support engineer needs to restart a virtual machine. They do not need permission to delete databases or change security settings, so they are given only limited access. This reduces risk and improves security. Simply remember, least privilege means give only required access, nothing extra. Scopes. Now let's understand scopes. Scopes define where a role applies. Access can be given at different levels. Subscription level, resource group level, resource level. Real workplace example. A developer may have access only to a single resource group for one project. They should not access the entire subscription. This ensures controlled and organized access. Simply remember, scopes define the boundary of access. Custom roles. Now let's talk about custom roles. Sometimes built-in roles are not enough. Organizations have unique requirements, so they create custom roles. Real workplace example. A company wants a special role. User can restart VMs but cannot delete them. There is no default role like this. So IT creates a custom role with specific permissions. This gives flexibility and control. Simply remember, custom roles are created for specific business needs. Governance. Now let's connect everything with governance. Governance means controlling and managing access in a structured and secure way. RBAC is one of the main tools for governance. Real workplace example. In a large enterprise, employees change roles. Projects start and end. Teams grow or shrink. Without RBAC, access becomes messy and risky. With RBAC, access is controlled. Permissions are organized. Security rules are enforced. Simply remember, governance ensures secure and organized access control. Bringing it all together, let's connect everything. Roles define permissions. Assignments give access to users. Least privilege ensures minimal access. Scopes define boundaries. Custom roles handle special requirements. Governance keeps everything secure and organized. Closing summary. Let's quickly recap. RBAC is a system that controls access based on roles. It ensures users get only the permissions they need. It reduces security risks and improves management. It works across different levels using scopes. It allows custom roles for business flexibility. And it follows the principle of least privilege. The key idea is simple. In a cloud environment, not everyone should have full access. RBAC ensures the right person gets the right access at the right time for the right resource. And that is why RBAC is one of the most important security foundations in Azure. Conditional access. Let me start with a real workplace situation. Imagine you are working in a company where employees can access Microsoft 365, Azure Portal, and internal applications from anywhere. Everything is working fine. But one day, the security team notices something unusual. A user logs in at 2 a.m. from a new country. Same username, correct password. But something feels wrong. Now the question is, should the system allow access just because the password is correct? Or should we check more conditions before allowing entry? This is exactly where conditional access comes in. What is conditional access? Think of conditional access as a smart security gate that does not just check who you are, but also checks where you are logging in from, what device you are using, how risky the login looks, what application you are trying to access. Based on all these conditions, it decides whether to allow or block access. Real workplace example. In a company building, not everyone is allowed entry just with an ID card. Security may also check timing, behavior, and clearance level. Similarly, conditional access evaluates multiple factors before allowing login. Simply remember, conditional access is smart security based on conditions, not just passwords. Policies. Now let's talk about policies. Policies are rules defined by the organization. They decide what should happen under certain conditions. Real workplace example. A company creates a policy. If user logs in from outside the country, require MFA. If user uses unmanaged device, block access. If login is from trusted device, allow access. These policies run automatically during every login attempt. Simply remember, policies are the rules that control access decisions. Risk-based access. Now let's understand risk-based access. This means access decisions are based on the level of risk detected during login. Real workplace example. A user logs in from their office every day. Suddenly, there is a login attempt from a new location, unusual device, and strange time. The system detects this as high risk. So instead of allowing access directly, it may block the login or ask for additional verification. Simply remember, risk-based access evaluates login behavior and detects suspicious activity. MFA. Multi-factor authentication. Now let's talk about MFA again, but in conditional access context. MFA is often enforced by conditional access policies. Real workplace example. If a user logs in from an unknown device, they are asked for password plus OTP. If they are on a trusted device, they may not be asked again. So MFA is applied intelligently based on conditions. Simply remember, MFA is enforced based on risk and policy conditions. Device compliance. Now let's talk about device compliance. This means checking whether a device is safe and managed by the company. Real workplace example. A company only allows access from company-managed laptops, encrypted devices, updated operating systems. If an employee tries to access from a personal or outdated device, access may be blocked. Simply remember, device compliance ensures only secure devices can access company data. Security. Now let's understand the main purpose. Security. Conditional access protects organizations from stolen passwords, unauthorized access, suspicious logins, data breaches. Real workplace example. Even if someone knows your password, they still cannot log in if they are on an unknown device, they are in a risky location, or they fail MFA verification. Simply remember, conditional access adds intelligent security beyond passwords. Examples. Now let's look at simple real-world examples. Example 1. If user logs in from Office network, allow access. Example 2. If user logs in from another country, require MFA. Example 3. If device is not compliant, block access. Example 4. If login is risky, restrict access to only basic apps. Real workplace example. In a banking company, employees can access systems normally from office devices. But if login happens from a personal phone in another country, extra verification is required. Simply remember, Conditional access changes access rules based on real-time conditions. Bringing it all together. Let's connect everything. Policies define rules. Risk-based access evaluates login behavior. MFA adds extra verification when needed. Device compliance ensures secure devices only. Security protects data and users from threats. Closing summary. Let's quickly recap. Conditional access is a smart security system in Microsoft Entra ID. It does not rely only on passwords. It evaluates conditions like location, device, and risk. It enforces policies automatically. Strengthens MFA based on context. It ensures only secure devices can access resources. The key idea is simple. Access is no longer just yes or no. It is now yes, but only if conditions are safe. And that is why conditional access is one of the most powerful security features in modern cloud identity systems. Azure Security. Let me start with a real workplace situation. Imagine you are working in a company that has fully moved to Azure. Everything is running fine. Web applications are live. Databases are working. Users are logging in from multiple locations. But one day, the security team notices something unusual. There are repeated login attempts from unknown IP addresses. At the same time, the application starts slowing down. And suddenly, there is a spike in traffic. Now the question is this normal traffic? Or a security attack? This is exactly where Azure Security comes in. What is Azure Security? Think of Azure Security as the complete protection system of your cloud environment. It is not just one tool. It is a combination of services that protect your applications, data, and infrastructure. Real workplace example. Just like a company has security guards, CCTV cameras, entry gates, firewalls, Azure has digital security services working together. Simply remember, Azure Security protects cloud resources from threats and attacks. Microsoft Defender for Cloud. Now let's talk about Microsoft Defender for Cloud. This is like a security monitoring system that continuously watches your Azure environment. Real workplace example. Imagine a security team monitoring all servers 24/7. If anything unusual happens, they get alerts. They detect vulnerabilities. They suggest fixes. Defender for Cloud does exactly this automatically in Azure. Simply remember, Defender for Cloud detects and protects against security threats. Firewall. Now let's talk about firewall. A firewall controls incoming and outgoing network traffic. It decides what is allowed and what is blocked. Real workplace example. Think of a security gate at an office building. Only authorized people can enter. Unknown visitors are stopped. Similarly, Azure Firewall filters network traffic. Simply remember, firewall controls network access to protect systems. DDoS protection. Now let's talk about DDoS attacks. DDoS stands for Distributed Denial of Service. It is when attackers flood your system with fake traffic to make it unavailable. Real workplace example. Imagine thousands of fake users trying to enter a website at the same time. The system becomes slow or crashes. Azure DDoS protection prevents this by detecting and blocking malicious traffic automatically. Simply remember, DDoS protection keeps applications available during traffic attacks. Encryption. Now let's talk about encryption. Encryption means converting data into a secure format so unauthorized users cannot read it. Real workplace example. When sensitive data like passwords or banking details are stored or transferred, Azure automatically encrypts it. Even if someone intercepts it, they cannot understand it. This keeps data safe both at rest and in transit. Simply remember, encryption protects data by making it unreadable to unauthorized users. Compliance. Now let's talk about compliance. Compliance means following security and legal standards. Real workplace example. A healthcare company must follow strict data protection rules. A financial company must follow audit regulations. Azure helps organizations monitor compliance status, follow industry standards, generate audit reports. Simply remember, Compliance ensures systems meet security and regulatory requirements. Monitoring. Now let's talk about monitoring. Monitoring means continuously watching the health and security of systems. Real workplace example. An IT team tracks login attempts, network traffic, application performance, security alerts. If something unusual happens, they get notified immediately. This helps prevent issues before they become major problems. Simply remember, monitoring helps detect issues early and maintain system health. Bringing it all together, let's connect everything. Defender for cloud detects threats and vulnerabilities. Firewall controls network traffic. DDoS protection blocks traffic-based attacks. Encryption protects sensitive data. Compliance ensures regulatory safety. Monitoring provides continuous visibility into security health. Closing summary. Let's quickly recap. Azure Security is a collection of services that protect cloud environments. It defends against cyber attacks and unauthorized access. It monitors systems continuously for threats. It encrypts data for safety. It ensures compliance with industry standards. It protects applications from network and traffic attacks. The key idea is simple. Security in Azure is not one single tool. It is a layered defense system working together. And that is why Azure Security is critical for every modern cloud environment, especially in enterprise organizations where data protection is the highest priority. Azure Key Vault. Let me start with a real workplace situation. Imagine you are working in a cloud development team. Your application is running in Azure. Connects to databases, APIs, storage accounts, third-party services. Now here is the problem. The application needs passwords, API keys, and certificates to work. But developers are doing something risky. They are storing secrets inside code files and sharing them through emails or chat messages. Now imagine this. What if someone gets access to the code? They also get access to everything. That is a serious security risk. This is exactly where Azure Key Vault comes in. What is Azure Key Vault? Think of Azure Key Vault as a highly secure digital locker in the cloud. It stores sensitive information safely and controls who can access it. It is designed specifically for secrets, keys, certificates. Real workplace example. Instead of writing database passwords in code, developers store them securely in Key Vault. Applications fetch them when needed. Nothing sensitive is exposed directly. Simply remember, Azure Key Vault securely stores and protects sensitive information. Secrets. Now let's talk about secrets. Secrets are sensitive pieces of information like passwords, API keys, connection strings. Real workplace example. A web application needs a database password. Instead of hard coding it, the password is stored in Key Vault. When the application runs, it retrieves the password securely. This prevents exposure of sensitive data. Simply remember, secrets are sensitive values stored securely in Key Vault. Certificates. Now let's talk about certificates. Certificates are digital identity files used for secure communication. Real workplace example. Company website uses HTTPS. It needs a certificate to encrypt communication between user and server. Instead of storing certificates in servers manually, they are stored in Key Vault. This ensures secure and centralized management. Simply remember, certificates in Key Vault help secure communication and identity. Keys. Now let's understand keys. Keys are cryptographic values used to encrypt and decrypt data. Real workplace example. Financial system encrypts customer data before storing it. The encryption key is stored securely in Key Vault. Only authorized services can use it to encrypt or decrypt data. Simply remember, keys are used to protect data through encryption. Security. Now let's talk about security. Security is the main purpose of Key Vault. It ensures only authorized users and applications can access sensitive data. Secrets are never exposed in code. Access is tightly controlled. Real workplace example. Even if a hacker accesses your application code, They cannot see passwords or keys. Because everything is stored securely in Key Vault. Simply remember, Key Vault is designed to protect sensitive information from exposure. Access policies. Now let's talk about access policies. Access policies define who can access what inside Key Vault. Real workplace example. A developer may be allowed to read secrets, but not allowed to delete or modify them. A security admin may have full control. Access is strictly controlled based on roles and permissions. Simply remember, access policies control who can access Key Vault data. Automation. Now let's talk about automation. Key Vault supports automation to make security easier. Real workplace example. Instead of manually updating passwords in applications, Key Vault automatically provides updated secrets. Applications retrieve them dynamically. Certificates can also be auto-renewed. This reduces human effort and errors. Simply remember, automation helps manage secrets without manual intervention. Bringing it all together, let's connect everything. Secrets store sensitive data like passwords. Certificates manage secure communication. Keys handle encryption and decryption. Security ensures data is protected. Access policies control who can access what. Automation reduces manual work and improves efficiency. Closing summary. Let's quickly recap. Azure Key Vault is a secure storage system for sensitive information. It stores secrets, certificates, and encryption keys. Protects data from unauthorized access. It enforces strict access policies. Supports automation for modern cloud applications. The key idea is simple. Never store sensitive data in your application code. Always store it securely in Key Vault. And that is why Azure Key Vault is a critical security service in modern cloud architecture, especially for enterprise-grade applications. Azure governance. Let me start with a real workplace situation. Imagine you are working in a large enterprise company that has hundreds of Azure subscriptions. Different teams are creating resources. Development team creates virtual machines. Testing team creates databases. Finance team creates storage accounts. And everything is happening fast. But after a few weeks, IT leadership notices a big problem. No proper naming standards. No cost tracking. Some resources are left unused. Security rules are inconsistent. Now the question is, how do you bring order, control, and discipline in such a large cloud environment? This is where Azure Governance comes in. What is governance? Think of governance as the rules, structure, and control system of your cloud environment. It ensures everything is organized, secure, cost-efficient, compliant. Real workplace example. In a company, there are rules for how employees behave, rules for approvals, rules for security, rules for expenses. Similarly, Azure Governance ensures cloud resources follow organizational rules. Simply remember, governance is about controlling and managing cloud resources in a structured way. Azure Policy. Now let's talk about Azure Policy. Azure Policy is used to enforce rules automatically. Real workplace example. Company says, all virtual machines must be deployed in approved regions only. All storage accounts must have encryption enabled. Instead of checking manually, Azure Policy enforces these rules automatically. If someone tries to create a non-compliant resource, it can be blocked or flagged. Simply remember, Azure Policy enforces rules across Azure resources. Management groups. Now let's understand management groups. Management groups help organize multiple subscriptions. Real workplace example. A large organization has one subscription for HR, one for finance, one for development. Instead of managing each separately, they are grouped under a management group. This allows policies and governance rules to be applied centrally. Simply remember, management groups provide hierarchical organization for subscriptions. Now let's talk about tags. Tags are simple labels added to Azure resources for identification. Real workplace example. A virtual machine can have tags like Environment equals production. Department equals finance. Owner equals a team. These tags help in tracking costs and managing resources easily. Simply remember. Tags help organize and identify Azure resources. Resource locks. Now let's understand resource locks. Resource locks prevent accidental deletion or modification of important resources. Real workplace example. A production database is critical. If someone accidentally deletes it, it can cause major business impact. So IT applies a lock. Delete not allowed, or read-only access only. This protects important resources. Simply remember. Resource locks protect critical resources from accidental changes. Compliance. Now let's talk about compliance. Compliance ensures that cloud resources follow industry rules and regulations. Real workplace example. A banking company must follow strict data protection laws. A healthcare company must follow patient data privacy rules. Azure helps organizations monitor compliance status, generate audit reports, ensure security standards are followed. Simply remember. Compliance ensures rules and regulations are followed in the cloud. Standards. Now let's talk about standards. Standards are predefined rules and best practices set by the organization. Real workplace example. A company defines standards like all resources must have tags. All storage must be encrypted. All VMs must follow naming conventions. Azure governance ensures these standards are applied consistently. Simply remember. Standards ensure consistency across all cloud resources. Bringing it all together. Let's connect everything. Azure Policy enforces rules automatically. Management groups organize subscriptions. Tags help identify and track resources. Resource locks protect critical resources. Compliance ensures regulatory requirements are met. Standards ensure consistency across the organization. Closing summary. Let's quickly recap. Azure Governance is the framework that controls and manages cloud resources. It ensures consistency, security, and compliance. It enforces rules using Azure Policy. It organizes subscriptions using management groups. Tracks resources using tags. Protects resources using locks. It ensures compliance with standards and regulations. The key idea is simple. Without governance, cloud becomes chaos. With governance, cloud becomes controlled, secure, and efficient. And that is why Azure Governance is one of the most important pillars in enterprise cloud architecture. Azure Cost Management. Let me start with a real workplace situation. Imagine you are working in a company that has just moved to Azure. Everything is exciting in the beginning. Teams are deploying virtual machines. Databases are created. Storage is expanding. New applications are going live every week. But after 1 month, the finance team calls an urgent meeting. Why is the cloud bill so high? Who created so many resources? Which team is spending how much? Now nobody has a clear answer. And this becomes a serious business problem. This is exactly where Azure Cost Management comes in. What is Azure Cost Management? Think of Azure Cost Management as the financial control system of the cloud. It helps organizations track spending, control budgets, analyze costs, optimize usage. Real workplace example. Just like a family tracks monthly expenses like rent, groceries, and bills, a company must track cloud spending across teams and services. Simply remember. Azure Cost Management helps control and monitor cloud spending. Budgets. Now let's talk about budgets. Budgets allow organizations to set spending limits. Real workplace example. Company says, development team can spend only $500 per month. If spending goes beyond that, alerts are triggered. This helps avoid unexpected bills. Simply remember. Budgets help control how much money is spent. Pricing calculator. Now let's talk about the pricing calculator. This tool helps estimate cost before deploying resources. Real workplace example. Before creating a virtual machine, a cloud engineer wants to know, how much will this VM cost per month? They use the pricing calculator to estimate expenses in advance. This helps in planning and decision-making. Simply remember, pricing calculator helps estimate cloud costs before usage. Reservations. Now let's talk about reservations. Reservations help reduce cost by committing to long-term usage. Real workplace example. A company knows it will use 10 virtual machines for the next 1 year. Instead of paying monthly at higher rates, they reserve capacity for 1 year or 3 years. This significantly reduces cost. Simply remember, reservations help save money by committing to long-term usage. Cost analysis. Now let's understand cost analysis. Cost analysis helps visualize and understand spending patterns. Real workplace example. A finance manager checks which department is spending the most, which services are expensive, where costs are increasing. This helps make informed financial decisions. Simply remember, cost analysis shows how and where money is being spent. Optimization. Now let's talk about optimization. Optimization means reducing unnecessary costs while maintaining performance. Real workplace example. A company finds some virtual machines are running 24/7 but not being used. Some storage is unused. Some resources are over-provisioned. By adjusting these, they reduce costs significantly. Simply remember, optimization helps reduce waste and improve efficiency. Advisor. Now let's talk about Azure Advisor. Azure Advisor is like a smart assistant that gives recommendations. Real workplace example. Azure Advisor suggests, your VM is underutilized, consider downsizing. You can save money by using reserved instances. You have idle resources that can be deleted. Provides actionable insights to reduce cost and improve performance. Simply remember, Azure Advisor gives smart recommendations for cost and performance improvement. Bringing it all together, let's connect everything. Budgets control spending limits. Pricing calculator estimates future costs. Reservations reduce long-term expenses. Cost analysis shows spending patterns. Optimization reduces waste. Advisor provides smart recommendations. Closing summary. Let's quickly recap. Azure Cost Management helps organizations control cloud spending. It ensures budgets are followed. It helps estimate costs before deployment. It reduces expenses through reservations. Provides insights through cost analysis. It improves efficiency through optimization. Gives recommendations through Azure Advisor. The key idea is simple. Cloud is powerful, but without cost control, it can become expensive very quickly. And that is why Azure Cost Management is essential for every organization using cloud at scale. Azure Monitor. Let me start with a real workplace situation. Imagine you are working in an IT operations team of a company. Everything is running smoothly in the morning. Web applications are working. Virtual machines are running. Databases are responding normally. But suddenly in the afternoon, users start reporting. The application is slow. Login is taking too long. Some pages are not loading. Now the IT team gets an alert. But they don't know the root cause immediately. Is it CPU issue, memory issue, network issue, or application failure? This is exactly where Azure Monitor becomes critical. What is Azure Monitor? Think of Azure Monitor as the eyes and ears of your entire Azure environment. It continuously watches everything: performance, health, activity, errors. It collects data and helps you understand what is happening inside your cloud systems. Real workplace example. Just like CCTV cameras monitor a building 24/7, Azure Monitor watches your cloud infrastructure continuously. Simply remember, Azure Monitor tracks performance and health of Azure resources. Metrics. Now let's talk about metrics. Metrics are real-time numerical data about system performance. Real workplace example. You check CPU usage, memory usage, disk performance, network traffic. If CPU is 90%, you immediately know something is wrong. Metrics give instant performance signals. Simply remember. Metrics show real-time performance numbers. Logs. Now let's understand logs. Logs are detailed records of events happening in your system. Real workplace example. A user tries to log in and fails. A log entry records. Time of login attempt. Username. Error message. Source IP address. Logs help you understand what exactly happened. Simply remember. Logs provide detailed event history. Alerts. Now let's talk about alerts. Alerts notify you when something goes wrong or crosses a threshold. Real workplace example. If CPU usage goes above 85%, Azure sends an alert to the IT team. If a virtual machine goes down, an alert is triggered immediately. This helps teams respond quickly before users are heavily impacted. Simply remember. Alerts notify you when something needs attention. Dashboards. Now let's understand dashboards. Dashboards provide a visual summary of system health. Real workplace example. An IT manager opens a dashboard and sees all VM status, application performance, div alerts, resource usage trends. Everything is visible in one place. This makes monitoring simple and fast. Simply remember. Dashboards give a visual overview of system health. Insights. Now let's talk about insights. Insights provide deep analysis and smart understanding of system behavior. Real workplace example. Azure Monitor insights can show why the application is slow, which service is causing delay, where bottlenecks exist. Instead of guessing, IT teams get intelligent analysis. Simply remember. Insights provide intelligent analysis of system performance. Operations. Now let's talk about operations. Operations means managing and maintaining systems in real time. Real workplace example. IT operations team continuously monitors systems, responds to alerts, fixes issues, ensures uptime. Azure Monitor helps operations teams act quickly and efficiently. Simply remember. Operations ensure systems run smoothly and continuously. Bringing it all together. Let's connect everything. Metrics show real-time performance. Logs show detailed events. Alerts notify issues immediately. Dashboards provide visual monitoring. Insights give deep analysis. Operations ensure continuous system stability. Closing summary. Let's quickly recap. Azure Monitor is the central monitoring system in Azure. It helps track performance and health of resources, collects metrics and logs. It triggers alerts when issues occur, provides dashboards for visualization. It delivers insights for troubleshooting. It supports IT operations teams in maintaining system uptime. The key idea is simple. You cannot manage what you cannot see. And Azure Monitor ensures you can see everything happening in your cloud environment in real time. That is why Azure Monitor is one of the most essential tools for maintaining reliable, high-performance cloud systems. Log analytics. Let me start with a real workplace situation. Imagine you are working in an IT operations team of a company. One morning, users report. The application is slow. The server is not responding properly. There is an unexpected error in the system. Now the monitoring dashboard shows there is a problem, but it does not clearly explain why it is happening. The IT team is confused. Is it a network issue, a server issue, an application failure, or a security issue? This is where log analytics becomes extremely powerful. What is log analytics? Think of log analytics as a powerful investigation engine for your Azure environment. It collects, stores, and analyzes logs from all your resources. And most importantly, it helps you find the root cause of problems. Real workplace example. Imagine a detective solving a case. Clues are scattered everywhere. Log analytics collects all those clues and connects the dots. Simply remember. Log analytics helps analyze logs to understand what is happening in your system. Workspaces. Now let's talk about workspaces. A workspace is like a central storage area for logs. Real workplace example. Company has virtual machines, web applications, databases. All of them send logs to a single log analytics workspace. This makes it easier to manage and analyze everything in one place. Simply remember, workspace is the central location where logs are stored. Queries. Now let's understand queries. Queries are used to search and filter log data. In Azure, we use KQL, Kusto Query Language. Real workplace example. An IT engineer wants to find all failed login attempts in the last 24 hours. Instead of manually checking everything, they run a query and instantly get results. Simply remember, queries help you search and analyze logs quickly. Monitoring. Now let's talk about monitoring. Log analytics plays a key role in monitoring systems. Real workplace example. Instead of just seeing CPU usage or alerts, engineers can dig deeper. Which process caused high CPU? Which user triggered an error? Which application failed? This gives complete visibility into system behavior. Simply remember, monitoring with log analytics gives deep system visibility. Troubleshooting. Now let's understand troubleshooting. Troubleshooting means finding and fixing the root cause of issues. Real workplace example. VM is running slow. Instead of guessing, engineers use logs to check CPU spikes, memory usage, error logs, network delays. Within minutes, they identify the real issue. Simply remember, log analytics helps quickly identify and fix problems. Reporting. Now let's talk about reporting. Reporting means creating insights from log data. Real workplace example. A monthly IT report shows number of failures, system downtime, performance trends, security incidents. This helps management make decisions. Simply remember, reporting converts logs into meaningful business insights. Security. Now let's talk about security. Log analytics is also used for security monitoring. Real workplace example. Security teams monitor failed login attempts, suspicious IP activity, unauthorized access attempts. They can detect attacks early and respond quickly. Simply remember, log analytics helps detect and analyze security threats. Bringing it all together, let's connect everything. Workspaces store all logs in one place. Queries help search and analyze data. Monitoring gives system visibility. Troubleshooting identifies root causes. Reporting provides insights for management. Security helps detect threats and attacks. Closing summary. Let's quickly recap. Log analytics is a powerful tool in Azure Monitor. It collects logs from all resources. It stores them in centralized workspaces. It allows querying using KQL. It helps in monitoring, troubleshooting, and reporting. It strengthens security visibility. The key idea is simple. Metrics tell you what is happening, but logs tell you why it is happening. And log analytics is the tool that helps you understand the full story behind your system behavior. That is why it is one of the most important tools for IT operations, troubleshooting, and security in Azure. Backup and recovery. Let me start with a real workplace situation. Imagine you are working in an IT team of a company that runs critical business applications in Azure. Everything is running smoothly. Virtual machines are online. Databases are working. Users are accessing applications. But suddenly, something unexpected happens. An employee accidentally deletes a production database. Or a ransomware attack locks important files. Or a virtual machine crashes during an update. Now the question is, how do you recover the lost data quickly without affecting the business? This is where backup and recovery becomes extremely important. What is backup and recovery? Think of backup and recovery as a safety net for your cloud environment. Backup means creating a copy of your data. Recovery means restoring that data when something goes wrong. Real workplace example. Just like you keep a spare key for your house, Azure keeps a safe copy of your data so it can be restored anytime. Simply remember, backup protects your data, recovery brings it back when needed. Azure Backup. Now let's talk about Azure Backup. Azure Backup is the main service that protects your data in Azure. It automatically takes backups of virtual machines, databases, file shares, applications. Real workplace example. Company runs a production server. Instead of manually copying data every day, Azure Backup automatically creates backup copies. So even if something fails, data is safe. Simply remember, Azure Backup automatically protects your data. Recovery Vault. Now let's understand Recovery Vault. A recovery vault is like a secure storage container for all your backups. Real workplace example. Think of it like a strong locker in a bank. All backup data is stored safely inside it. Even if a system fails, the backup remains protected in the vault. Simply remember, Recovery Vault stores and manages backup data securely. Retention. Now let's talk about retention. Retention means how long backup data is kept before it is deleted. Real workplace example. A company may keep daily backups for 7 days, weekly backups for 4 weeks, monthly backups for 1 year. This ensures data is available when needed for recovery or audits. Simply remember, retention defines how long backups are stored. Protection. Now let's understand protection. Protection ensures that critical data is backed up properly. Real workplace example. Production database is marked as protected. This means backups are automatically taken. Policies are applied. Data is safeguarded against accidental loss. Even if someone deletes the resource, recovery is possible. Simply remember, protection ensures data is always backed up and safe. Recovery. Now let's talk about recovery. Recovery means restoring data back to its original state after failure. Real workplace example. A user accidentally deletes important files. A team goes to Azure Backup, selects a restore point, restores the data within minutes. Business continues without major downtime. Simply remember, recovery brings back lost or damaged data. Compliance. Now let's talk about compliance. Compliance ensures backup systems meet legal and business regulations. Real workplace example. A financial company must keep records for several years. Even if data is deleted from production, backups must be retained for audit purposes. Azure Backup helps meet these requirements automatically. Simply remember, compliance ensures backup data meets legal and regulatory standards. Bringing it all together, let's connect everything. Azure Backup creates copies of data. Recovery Vault securely stores backups. Retention defines how long backups are kept. Protection ensures critical data is always backed up. Recovery restores data when needed. Compliance ensures regulatory requirements are met. Closing summary. Let's quickly recap. Backup and recovery is a critical part of cloud security and reliability. It protects against accidental deletion, system failure, and cyber attacks. It ensures data is always recoverable. It uses Recovery Vault for secure storage. It follows retention policies for data management. It supports compliance requirements for enterprises. The key idea is simple. Mistakes, failures, and attacks will happen in IT systems. Backup and recovery ensures that none of them become permanent disasters. And that is why it is one of the most essential services in Azure for business continuity and data protection. Azure Site Recovery. Let me start with a real workplace situation. Imagine you are working in a company that runs its main application in a data center. Everything is running fine. Users are accessing the system. Orders are being processed. Reports are generated every day. But suddenly, something serious happens. Power failure in the primary data center, or a natural disaster, or a major hardware crash, and the entire system goes down. Now the business is completely stopped. No access, no transactions, no operations. This is the worst-case scenario for any IT team. So the question is, how do we keep the business running even when the main system fails? This is where Azure Site Recovery comes in. What is Azure Site Recovery? Think of Azure Site Recovery as a disaster protection system for your applications. It ensures that if your primary system fails, a secondary system can take over immediately. Real workplace example. Just like a hospital has an emergency backup generator, Azure Site Recovery ensures your applications keep running even during failures. Simply remember, Site Recovery keeps your business running during disasters. Disaster recovery. Now let's talk about disaster recovery. Disaster recovery means recovering systems after a major failure. Real workplace example. A company's primary server goes down due to a fire accident in the data center. Instead of waiting for repairs, systems are restored in Azure within minutes. This prevents long downtime. Simply remember, disaster recovery ensures systems can be restored after failure. Replication. Now let's understand replication. Replication means continuously copying data from one location to another. Real workplace example. A company's production server is in on-premises data center. Azure Site Recovery continuously copies that data to Azure. So if the primary server fails, the backup is already ready. Simply remember, replication keeps a live copy of your system in another location. Failover. Now let's talk about failover. Failover means switching from the primary system to the backup system. Real workplace example. The main server goes down. Instead of waiting for repair, users are automatically redirected to the backup system in Azure. Business continues without interruption. Simply remember, failover switches operations to backup systems during failure. Testing. Now let's understand testing. Testing means checking whether disaster recovery will actually work when needed. Real workplace example. An IT team performs a test failover. They simulate a disaster, switch to backup environment, check if applications run properly. Once confirmed, they switch back. This ensures readiness during real emergencies. Simply remember, testing ensures disaster recovery works correctly. Business continuity. Now let's talk about business continuity. Business continuity means keeping the business running even during disruptions. Real workplace example. Even if the primary data center is down, employees and customers can still use applications from Azure. Business operations continue without major impact. Simply remember, business continuity ensures business never stops. Hybrid. Now let's understand hybrid scenarios. Hybrid means combining on-premises and cloud systems. Real workplace example. Company runs its main system on-premises, but uses Azure Site Recovery as a backup environment. If on-premises fails, Azure takes over. This gives flexibility and safety. Simply remember, hybrid disaster recovery combines on-prem and cloud protection. Bringing it all together, let's connect everything. Replication continuously copies data to Azure. Failover switches systems during failure. Testing ensures recovery plans work. Business continuity keeps operations running. Hybrid setups combine on-prem and cloud protection. Closing summary. Let's quickly recap. Azure Site Recovery is a disaster recovery solution in Azure. It protects applications from system failures and disasters. It uses replication to keep data updated. It uses failover to switch systems during failure. It allows testing to ensure readiness. It ensures business continuity during outages. It supports hybrid cloud environments. The key idea is simple. Failures are not optional in IT systems, but downtime is optional. And Azure Site Recovery ensures your business keeps running even when disasters happen. That is why it is one of the most critical services for enterprise-grade resilience in Azure. Hybrid Azure. Let me start with a real workplace situation. Imagine you are working in a company that has been running IT systems for many years on premises. They have a data center in their office, physical servers, Active Directory, file servers, business applications running locally. Now the company decides to move to the cloud. But here is the reality. Not everything can move at once. Some applications are old and critical. Some systems need local access. Some data must stay on premises for compliance. So now the company is stuck in between. On-premises plus cloud. This is exactly where hybrid Azure comes in. What is hybrid Azure? Think of hybrid Azure as a bridge between your on-premises data center and the Azure cloud. It allows both environments to work together as one system. Real workplace example. Company still runs payroll on-premises, but uses Azure for web applications and analytics. Both systems are connected and work seamlessly. Simply remember, hybrid Azure connects on-premises systems with Azure Cloud. Azure Arc. Now let's talk about Azure Arc. Azure Arc extends Azure management to anywhere. That means on-premises servers, multi-cloud environments, edge locations. Real workplace example. Company has some servers in Azure, some in AWS, some in their local data center. With Azure Arc, they can manage everything from one place. Simply remember, Azure Arc brings all environments under one management system. VPN. Now let's talk about VPN. VPN stands for Virtual Private Network. It creates a secure connection between on-premises and Azure over the Internet. Real workplace example. Employees in office access Azure resources through a secure encrypted tunnel. Even though they use the Internet, data remains protected. Simply remember, VPN provides secure connection between on-premises and Azure. ExpressRoute. Now let's understand ExpressRoute. ExpressRoute is a private connection between on-premises and Azure. It does not go through the public Internet. Real workplace example. A large bank connects its data center to Azure using a dedicated private line. This gives faster speed, higher reliability, better security. Simply remember, ExpressRoute provides private high-speed connection to Azure. Migration. Now let's talk about migration. Migration means moving applications and data from on-premises to Azure. Real workplace example. A company moves file servers, virtual machines, databases to Azure Cloud. This reduces hardware dependency and improves scalability. Simply remember, migration moves workloads from on-premises to Azure. On-prem integration. Now let's understand on-prem integration. This means both on-premises systems and Azure systems work together. Real workplace example. A company keeps its legacy application on-premises, but connects it to Azure for storage and backup. Both systems communicate seamlessly. Simply remember, on-prem integration allows hybrid systems to work together. Management. Now let's talk about management. Hybrid environments can become complex, so centralized management is important. Real workplace example. Teams use Azure tools to monitor on-prem servers, manage cloud resources, apply security policies, track performance from one dashboard. This simplifies operations. Simply remember, hybrid management provides unified control of all systems. Bringing it all together, let's connect everything. Azure Arc manages all environments centrally. VPN provides secure internet-based connectivity. ExpressRoute provides private high-speed connectivity. Migration moves workloads to the cloud. On-prem integration connects both environments. Management ensures centralized control. Closing summary. Let's quickly recap. Hybrid Azure is a combination of on-premises and cloud environments. It allows organizations to move to cloud at their own pace. It ensures systems work together seamlessly. It uses VPN for secure connectivity. It uses ExpressRoute for private connectivity. It uses Azure Arc for unified management. It supports migration and integration of workloads. The key idea is simple. Not every company can go 100% cloud immediately. Hybrid Azure allows a smooth, safe, and flexible transition. And that is why it is one of the most important strategies for real-world enterprise cloud adoption. Azure Migration. Let me start with a real workplace situation. Imagine you are working in a company that has been running its IT systems for 10 to 15 years on premises. They have physical servers, old applications, databases running in local data center. And now the business says, We want to move everything to Azure. Sounds simple. But in reality it is not. Because you cannot just move systems blindly. You need planning, analysis, testing, and careful execution. This is exactly where Azure Migration comes in. What is Azure Migration? Think of Azure Migration as the complete journey of moving applications, data, and infrastructure from on-premises to Azure Cloud. It is not a single step. It is a structured process. Real workplace example. Just like shifting an entire office to a new building. You first check what to move. Then pack everything carefully. Test setup in new location. Finally shift and operate smoothly. Simply remember. Azure Migration is the process of moving workloads from on-premises to Azure in a planned way. Assessment. Now let's talk about assessment. Assessment means understanding your current environment before migration. Real workplace example. An IT team analyzes how many servers are running, which applications are critical, which systems are outdated, which workloads are suitable for cloud. This helps avoid surprises during migration. Simply remember, assessment helps understand what you currently have. Discovery. Now let's understand discovery. Discovery means identifying all IT assets in your environment. Real workplace example. Sometimes companies don't even know how many virtual machines exist, which applications are still active, which services are unused. Discovery tools scan the entire environment and create a complete inventory. Simply remember, discovery finds and lists all existing resources. Migration tools. Now let's talk about migration tools. These tools help move workloads to Azure safely and efficiently. Real workplace example. Microsoft provides tools like Azure Migrate to move virtual machines, move databases, assess readiness, plan migration steps. This reduces manual effort and risk. Simply remember, migration tools automate and simplify cloud migration. Testing. Now let's understand testing. Testing ensures everything works correctly before full migration. Real workplace example. Before switching completely IT teams. Run applications in Azure environment. Check performance. Validate functionality. Fix issues before going live. This avoids downtime during migration. Simply remember, testing ensures everything works before final move. Cutover. Now let's talk about cutover. Cutover is the final step where systems switch from on-premises to Azure. Real workplace example. After successful testing, users are redirected to Azure systems. Old systems are shut down or kept as backup. Business starts running fully on cloud. This is the most critical phase. Simply remember, cutover is the final switch to Azure. Optimization. Now let's understand optimization. Optimization happens after migration is complete. Real workplace example. Once systems are running in Azure IT teams. Reduce unnecessary resources. Improve performance. Lower cloud costs. Adjust scaling settings. This ensures efficient cloud usage. Simply remember, optimization improves performance and reduces cost after migration. Bringing it all together. Let's connect everything. Assessment studies the current environment. Discovery identifies all resources. Migration tools move workloads to Azure. Testing ensures systems work properly. Cutover switches operations to cloud. Optimization improves performance and cost. Closing summary. Let's quickly recap. Azure migration is a structured process of moving workloads to Azure. It ensures safe and smooth transition from on-premises systems. It begins with assessment and discovery. It uses tools to simplify migration. It includes testing before go-live. It ends with cutover and optimization. The key idea is simple. Migration is not just moving systems. It is planning, testing, executing, and improving. And that is why Azure migration is one of the most important journeys for organizations adopting cloud technology. Azure support plans. Let me start with a real workplace situation. Imagine you are working in a company where all applications are running on Azure. Everything is fine during normal hours. But suddenly at night, a production server goes down. Users cannot access the application. Business operations are stuck. Now the IT team needs urgent help from Microsoft support. But here is the key question. How fast will Microsoft respond? And more importantly, what level of support does the company actually have? This is where Azure support plans come in. What are Azure support plans? Think of Azure support plans as different levels of technical assistance provided by Microsoft. The higher the plan, the faster the response and better the support. Real workplace example. Just like insurance plans, basic coverage gives limited support. Premium plans give faster and dedicated support. Azure works the same way. Simply remember, Azure support plans define how much support you get and how fast you get help. Basic plan. Now let's talk about the basic plan. This is the default free support plan. Real workplace example. A small developer is learning Azure. They face an issue. They use documentation, forums, and community help instead of direct Microsoft support. There is no guaranteed response time. Simply remember, basic plan equals self-service support only. Developer plan. Now let's understand the developer plan. This plan is for testing and non-production environments. Real workplace example. A developer is building a new application. They need technical help during development phase. If an issue occurs, they can raise a support ticket and get assistance during working hours. But it is not for production systems. Simply remember, developer plan equals support for development and testing environments. Standard plan. Now let's talk about the standard plan. This is for production workloads with faster response times. Real workplace example. A company runs a live e-commerce website on Azure. If the site goes down, they need quick support. With standard plan, Microsoft provides faster response and technical assistance. Simply remember, standard plan equals production support with faster response. Professional direct plan. Now let's understand the professional direct plan. This is for critical business environments. Real workplace example. A large financial company runs mission-critical applications. Any downtime means financial loss. With professional direct plan, they get priority support, faster response times, access to expert engineers, even proactive guidance. Simply remember, professional direct equals high-priority enterprise support. Response times. Now let's talk about response times. Response time is how quickly Microsoft responds to a support ticket. Real workplace example. A critical production issue. Professional direct responds very quickly. Standard is moderately fast. Developer is slower. Basic has no guaranteed response. Simply remember, higher support plan equals faster response time. Cases. Now let's understand support cases. A case is a support request raised when something goes wrong. Real workplace example. An IT engineer creates a support ticket. VM is not starting in production. Microsoft support engineers then investigate and help resolve the issue. Each issue becomes a tracked case until it is resolved. Simply remember, support cases are tickets raised for help and issue resolution. Bringing it all together, let's connect everything. Basic provides self-service help. Developer supports testing environments. Standard supports production workloads. Professional direct supports critical enterprise systems. Response times improve with higher plans. Cases are support tickets for resolving issues. Closing summary. Let's quickly recap. Azure support plans define the level of Microsoft support you receive. They range from basic to professional direct. They determine response speed and support quality. They help organizations choose support based on business criticality. The key idea is simple. Not all systems need the same level of support. A learning environment needs basic help. Production banking system needs premium support. And that is why choosing the right Azure support plan is very important for business continuity and operational success. Real-world IT support tasks. Let me start with a real workplace situation. Imagine you are working as an IT support engineer in a company that runs most of its infrastructure on Azure. It's Monday morning. Everything looks normal. Until the help desk starts lighting up. Users are reporting. I cannot log in to the system. My application is not working. The server is slow. Shared files are missing. Now suddenly you are not just managing cloud services. You are responsible for keeping the entire business running. This is what real-world IT support in Azure looks like. Let's go through the most common tasks you handle every day. User access. Let's start with user access. This is one of the most frequent IT support tasks. Real workplace example. A new employee joins the company. They say, I cannot access my email or application portal. You check Microsoft Entra ID and RBAC permissions. You assign correct roles and fix access. Or sometimes a user forgets password and needs reset. Simply remember. User access means managing login, permissions, and identity issues. VM management. Now let's talk about VM management. Virtual machines are the backbone of many cloud systems. Real workplace example. A user reports. The application hosted on VM is not responding. You check VM status, CPU and memory usage. Restart if required. Apply updates or extensions. Sometimes you scale up the VM if performance is low. Simply remember, VM management means maintaining virtual machines and their performance. Monitoring. Now let's understand monitoring. Monitoring helps you detect issues before users complain. Real workplace example. Azure Monitor shows high CPU usage, service downtime, application errors. You receive alerts and take action immediately. This prevents major outages. Simply remember, monitoring means continuously tracking system health and performance. Storage. Now let's talk about storage support. Storage issues are very common in real environments. Real workplace example. A user says, I cannot access shared files. You check Azure Storage or Azure Files. Permissions, access keys, network rules. Sometimes storage is full or misconfigured. Simply remember, storage support means managing access and availability of data. Networking. Now let's understand networking issues. Networking is one of the most critical and complex areas. Real workplace example. Users report. Application is not reachable. You check. Virtual network configuration. NSG rules. DNS resolution. Load balancer settings. VPN or ExpressRoute connectivity. One small misconfiguration can break the entire system. Simply remember. Networking means ensuring systems can communicate properly. Troubleshooting. Now let's talk about troubleshooting. Troubleshooting is the heart of IT support. Real workplace example. A web application is slow. You don't guess the issue. You investigate step by step. Check logs. Analyze metrics. Review network traffic. Identify root cause. Fix the issue permanently. Simply remember. Troubleshooting means finding and fixing the root cause of problems. Bringing it all together. Let's connect everything. User access ensures correct login and permissions. VM management keeps servers running smoothly. Monitoring detects issues early. Storage ensures data availability. Networking ensures connectivity. Troubleshooting solves real problems. Closing summary. Let's quickly recap. Real-world IT support in Azure is not just about fixing issues. It is about keeping systems running, ensuring users can work without interruption, solving problems quickly and efficiently, maintaining business continuity. The key idea is simple. When users see problems, IT support sees responsibility. And that is why Azure IT support roles are critical in every modern organization that runs on cloud infrastructure. AZ 900 exam preparation. Let me start with a real workplace situation. Imagine you are working in IT support or a cloud team. You are already learning Azure step by step. Everything makes sense in practice. But then someone says, Why don't you certify it? Take AZ900. Now suddenly it becomes serious. Because this is not just learning anymore. This is an exam. And many people feel confused at this stage. What should I study? Where do I start? How do I remember everything? So let's break it down in a simple, structured way. What is AZ900? AZ900 is Microsoft Azure Fundamental Certification. Tests your basic understanding of cloud concepts, Azure services, security, pricing and support. Real workplace example. Think of it like learning driving basics before going for a driving license test. You don't need advanced skills. You need clear fundamentals. Simply remember, AZ900 tests your basic understanding of Azure Cloud. Domains. Now let's talk about exam domains. Domains are the main topics of the exam. Real breakdown. You will be tested on cloud concepts, core Azure services, security, privacy and compliance, pricing and support. Real workplace example. It's like a company training program. You are not tested on one tool. You are tested on multiple areas of cloud knowledge. Simply remember, domains are the main sections of the AZ900 exam. Study plan. Now let's talk about study plan. A study plan is how you organize your learning step by step. Real workplace example. You don't learn everything in one day. You divide it. Day 1 to 2, Cloud Basics. Day 3 to 5, Azure Services. Day 6 to 7, Security and Governance. Final days. Revision. This makes learning structured and easy. Simply remember, a study plan helps you learn Azure step by step without confusion. Labs. Now let's understand labs. Labs are practical hands-on exercises. Real workplace example. You don't just read about VM creation, storage accounts, Azure Portal usage. You actually create them in Azure environment. This builds real confidence. Simply remember, labs help you learn by doing, not just reading. Practice test. Now let's talk about practice tests. Practice tests simulate real exam questions. Real workplace example. Before final exam you take mock tests, multiple choice questions, scenario-based questions, time test. This helps you understand question patterns. Simply remember, practice tests prepare you for real exam format. Revision. Now let's understand revision. Revision means reviewing everything you learned repeatedly. Real workplace example. Before exam day you go through key concepts, important services, common mistakes. This strengthens memory and confidence. Simply remember, revision helps you retain knowledge before the exam. Exam day tips. Now let's talk about exam day tips. This is very important for success. Real workplace example. On exam day, stay calm. Read questions carefully. Eliminate wrong answers. Manage time properly. Don't rush. Even if one question is confusing, move ahead and come back later. Simply remember, exam success depends on clarity, not speed. Bringing it all together. Let's connect everything. Domains define what to study. Study plan organizes your learning. Labs give hands-on experience. Practice tests prepare you for real questions. Revision strengthens memory. Exam day tips help you perform well. Closing summary. Let's quickly recap. AZ900 is a foundational Azure certification. Tests basic cloud knowledge. It requires structured preparation. Combines theory, practice, and revision. It evaluates your understanding of core Azure concepts. The key idea is simple. AZ900 is not about memorizing. It is about understanding how cloud works in real-world scenarios. And with the right preparation, practice, and confidence, you can clear it successfully and take your first strong step into the Azure cloud journey. Z104 Roadmap. Let me start with a real workplace situation. Imagine you are no longer just supporting users. Now you are part of the core cloud operations team. Your company is fully running on Azure. And suddenly something changes. A virtual machine is slow. A user cannot access storage. A network connection breaks. A new employee cannot log in. Now everything depends on you. Not just fixing issues, but managing the entire Azure environment. This is exactly where AZ-104 comes in. What is AZ-104? AZ-104 is the Microsoft Azure Administrator certification. It focuses on real-world Azure administration tasks. Not theory, but actual operations. Real workplace example. It is like moving from support engineer to cloud administrator. You are now responsible for managing identity, networking, storage, compute, monitoring. Simply remember, AZ-104 prepares you for real Azure administration roles. Administration. Let's start with administration. Administration means managing Azure resources and subscriptions. Real workplace example. Create virtual machines. Manage subscriptions. Sign roles. Handle resource groups. Control access and policies. This is daily cloud operations work. Simply remember, administration is managing Azure resources efficiently. Networking. Now let's talk about networking. Networking is one of the most critical areas in AZ-104. Real workplace example. You handle virtual networks, VNets, subnets, NSGs, load balancers, VPN connectivity. One small misconfiguration can break application access. Simply remember, networking ensures secure communication between resources. Storage. Now let's understand storage. Storage is where all data lives in Azure. Real workplace example. You manage Azure storage accounts, Blob Storage, file shares, access permissions, backup storage. Users complain when they cannot access files. You fix access or configuration issues. Simply remember, storage ensures data is available, secure, and accessible. Identity. Now let's talk about identity. Identity is managed using Microsoft Entra ID. Real workplace example. Create users. Assign roles using RBAC. Manage login issues. Configure authentication policies. Fix access problems. If identity breaks, nothing works. Simply remember, identity controls who can access what. Monitoring. Now let's understand monitoring. Monitoring helps you keep systems healthy. Real workplace example. You use Azure Monitor, log analytics, alerts and dashboards to detect issues before users complain. If CPU is high or VM is down, you react quickly. Simply remember, monitoring ensures system health and performance visibility. Career growth. Now let's talk about career growth. This is where AZ-104 becomes very powerful. Real workplace example. After AZ-104, you are not just a support engineer anymore. You become Azure Administrator, Cloud Operations Engineer, System Engineer, Cloud. You handle real production environments, and your responsibilities increase significantly. Simply remember, AZ-104 is a gateway to cloud administration careers. Bringing it all together. Let's connect everything. Administration manages Azure resources. Networking connects systems securely. Storage manages and protects data. Identity controls access and security. Monitoring ensures system health. Career growth moves you into cloud roles. Closing summary. Let's quickly recap. AZ-104 is a hands-on Azure administration certification. Focuses on real-world cloud management tasks. It builds skills in networking, storage, identity, and monitoring. It prepares you for operational responsibilities in Azure. The key idea is simple. AZ-104 is not just an exam. It is a transition from learning Azure to managing Azure in real production environments. And that is why AZ-104 is one of the most important steps for anyone aiming to build a strong career in cloud administration and IT operations. Azure interview questions. Let me start with a real interview situation. Imagine you are sitting in an interview room for an Azure support or cloud administrator role. The interviewer smiles and says, "Let's start with some basics." At that moment, everything you studied, Azure fundamentals, services, concepts, comes into play. But here is the truth. They are not just checking your memory. They are checking how you think in real IT scenarios. So let's break down the most important interview areas. Azure Basics. Let's start with Azure Basics. Common questions. What is Microsoft Azure? What is cloud computing? What are the types of cloud models? What are Azure regions and availability zones? What interviewers expect? They want to hear simple real understanding, not textbook definitions. Real answer thinking. Azure is a cloud platform that provides computing, storage, networking, and security services over the internet. Cloud means using resources without owning physical hardware. Simply remember, Azure Basics test your understanding of cloud fundamentals. Identity Entra ID. Now let's talk about identity questions. Common questions. What is Microsoft Entra ID? What is authentication versus authorization? What is MFA? What is RBAC? What interviewers expect? They want to know how you control access in real environments. Real scenario thinking. A user cannot access application, check identity, reset password, verify role assignment. Simply remember. Identity questions test user access and security understanding. Networking. Now let's move to networking. Common questions. What is VNet? What is subnet? What is NS? What is VPN versus ExpressRoute? What is load balancer? What interviewers expect? They want troubleshooting mindset. Real scenario thinking. Application not reachable, check NSG rules, verify subnet, check routing, fix connectivity. Simply remember. Networking questions test how systems communicate. Storage. Now let's talk about storage. Common questions. What is Azure Storage account? What is Blob Storage? What is Azure Files? What are storage tiers? How do you manage access? What interviewers expect? They want understanding of data storage and access control. Real scenario thinking. User cannot access file share, check permissions, check keys, check firewall settings. Simply remember. Storage questions test data management skills. Security. Now let's talk about security. Common questions. What is Azure Security Center, Defender for Cloud? What is encryption? What is Key Vault? What is conditional access? How do you secure Azure resources? What interviewers expect? They want security-first thinking. Real scenario thinking. Suspicious login, conditional access, MFA, block unknown device, investigate logs. Simply remember. Security questions test protection of cloud resources. Scenario questions. Most important. Now let's talk about scenario-based questions. This is where interviews are decided. Example questions. VM is slow. What will you check? User cannot log in. How do you troubleshoot? Application is not reachable. What steps will you follow? Storage access is failing. What could be the issue? What interviewers expect? They don't want single answers. They want step-by-step thinking. Real approach. Check monitoring, check logs, verify configuration, isolate issue, fix root cause. Simply remember. Scenario questions test your real troubleshooting ability. Bringing it all together. Let's connect everything. Azure Basics test cloud understanding. Identity tests access and authentication. Networking tests connectivity and troubleshooting. Storage tests data handling. Security tests protection and compliance. Scenario questions test real-world thinking. Closing summary. Let's quickly recap. Azure interviews are not about memorizing definitions. They are about understanding real IT situations. They test how you think, troubleshoot, analyze, solve problems. The key idea is simple. If you can explain Azure concepts using real workplace examples, you are already ahead in interviews. And that is why scenario-based understanding is the most powerful skill for cracking Azure interviews successfully. Azure summary. Let me wrap everything up with a real workplace picture. Imagine you are now working in a company that has fully moved to Azure. Not just learning anymore, but actually supporting users, managing systems, and handling real business workloads. One day you sit in a meeting and your manager says, We are now fully cloud-based. I need a complete overview of what we are running and how it is managed. At that moment, everything you learn starts connecting together. Let's bring it all into one clear story. Cloud concepts. Let's start with cloud concepts. Cloud is simply using computing resources over the internet instead of physical servers. Real workplace example. Instead of buying servers and keeping them in a data center, companies use Azure to run everything online. They pay only for what they use. Simply remember, cloud means on-demand IT services over the internet. Core services. Now let's talk about core services. Azure is built on a few main pillars: compute, storage, networking, databases. Real workplace example. Every application depends on these. VMs run applications. Storage holds data. Networking connects systems. Databases manage information. Simply remember, core services are the building blocks of Azure. Security. Now let's understand security. Security ensures your data and systems are protected. Real workplace example. Even if everything is in the cloud, you still protect it using Entra ID for identity, MFA for login security, Key Vault for secrets, Defender for threats. Simply remember, security protects cloud resources from unauthorized access and attacks. Governance. Now let's talk about governance. Governance is about control, rules, and structure. Real workplace example. A company ensures only approved resources are created. Cost is controlled. Tags are applied. Policies are enforced. Simply remember, governance keeps cloud environments organized and compliant. Monitoring. Now let's understand monitoring. Monitoring means keeping an eye on everything running in Azure. Real workplace example. Teams track system health, performance, errors, security alerts. If something goes wrong, they respond immediately. Simply remember, monitoring ensures systems are healthy and reliable. Next steps. Now let's talk about next steps. At this stage, you are not just learning Azure anymore. You are preparing for real-world roles. Real workplace example. You can move into roles like Azure Administrator, Cloud Support Engineer, Cloud Operations Engineer, then grow into Azure Architect, Security Engineer, Cloud Consultant. Simply remember, next steps are about building real career growth in cloud. Bringing it all together. Let's connect everything. Cloud concepts explain what cloud is. Core services are the foundation of Azure. Security protects everything. Governance controls everything. Monitoring watches everything. Next steps guide your career path. Closing summary. Let's quickly recap. Azure is a complete cloud platform that helps organizations run IT systems without physical infrastructure. It provides powerful core services, strong security, clear governance, continuous monitoring, and strong career opportunities. The key idea is simple. Azure is not just a technology. It is a complete ecosystem that powers modern businesses. And once you understand these fundamentals clearly, you are ready to move from learning cloud to working in real cloud environments confidently.